Ladies and gentlemen, live from Boulder, Colorado, this is the HCI Build Day with NetApp. And now, for your viewing pleasure, Alistair Cook.
Thank you, Jeffrey, and it is awesome to be here in beautiful Boulder, Colorado. Spectacular mountains rising up beside us, and also we are right in the middle of downtown Boulder, so there are lovely boutique shops all around outside that unfortunately we haven't seen because we've been here inside NetApp's offices for the whole of our time here in Boulder. Now, Build Day Live, as you know, is an independent organization. We bring you the inside scoop on what it's like to deploy real IT infrastructure products in something close to what you might see in the real world. We are independent, but of course we do this with vendors, so we are here today with NetApp as their guests, and they've supported us to be here. But the content, my opinions, of course, are my own and expressed really freely here. The nice thing is that everything has been working smoothly for us, and so I've been saying nice things all week. Joining me on camera, playing the role of the support engineer, because I play the role of the customer, is Kevin Paprick. Kevin, what do you do here?
Yeah, so my name is Kevin Paprick, and I am a solutions architect, part of our cloud infrastructure business unit, focused on our NetApp HCI and StorageGRID product lines. So I've been here for 3 years and focused in the field, whether it's from helping position our products to helping support deployments and other aspects throughout since the launch of our NetApp HCI product.
And you're based in Chicago, but regionally around the whole Northeast?
That is correct. I am based out of Chicago. I work in, mostly central based, but I've also been Americas based since I've started here.
Right. And the center of what we're showing this week is the NetApp HCI solution. So we're starting with a basic vSphere environment because at this stage that's the hypervisor that the HCI platform supports. And it's a fairly simple environment that we're starting with, but what is it that we're going to be building out? What have we got sitting in the back room so it's not too noisy here?
Yeah, so what we have built out and what we're building out is we're going to start out with our HCI deployment. So this is going to have 2 independent compute nodes that will deploy ESX, vSphere, onto them. We'll also have 4 storage nodes. But in addition to that, after we run through this deployment, we're going to show how easy it is to expand our clusters as well. So we'll be adding a storage node independently, and then also a compute node to the cluster.
And that's one of the consistent themes we'll see through this is that there are 2 independent but intertwined clusters in this. The difference within NetApp HCI is that the storage cluster and the compute cluster aren't co-located. They're 2 discrete clusters that you can scale independently, but that you manage as a unified whole.
That is correct, and that's one of the biggest differentiators of our products, and one of the biggest reasons I see our customers not only choosing NetApp HCI, but really then taking what they purchase and grow that out to continue to deploy based on that simplicity and scalability that we have.
And that's the feedback I've had from some customers is they weren't interested in deploying HCI because as you scale beyond 8, 10 nodes of HCI, your east-west traffic between the nodes starts to be problematic. And that's where separating out and having a smaller storage cluster that doesn't have to occupy the whole space of your 20-node vSphere cluster avoids that scaling of the east-west traffic as you get to a larger cluster.
Yes, definitely. We just had a large retail win that just came off of the competitive platform because of that reason. They started seeing that they bought this product and went down an HCI route for that simplicity aspect. But what they realized is after a while, they're running it a year or 2, they start having all these separate silos of clusters because of that limitation of only being able to scale that 8 or 10 nodes that you just mentioned, Alistair. So what they just purchased was bringing in NetApp HCI to solve that, being able to truly intermix different application workloads on a single platform and have that independent scalability to add just storage if they need it without limitations.
And you still get that storage cluster size limit that we still only want 8 to 10 storage nodes to perform the cluster, and they scale fairly large, but you're still staying at a reasonably small size, but that doesn't then limit your compute from getting out to the full 64 that vSphere supports.
Yeah, so we have customers that will go that full 64 compute nodes, but it's also on the storage nodes. So we can go up to 40 storage nodes. Okay. We start at 4, but we can continue to scale that out.
Still goes out to pretty large numbers. Okay, now let's very quickly look at the environment that I've built. So take a look at my screen here. And The nice thing was we chose to bring a very small lab environment here. I just brought a single vSphere server, a single ESXi host in here, built as usual with my AutoLab build, and so it's a single server. It's got a small number of virtual machines on it. And really, we're not going to take a lot off here other than making sure that we're working with a brownfield environment. So it should be familiar to people who have watched previous Build Day Live events that we run with a simple environment, but we have only a single host. I haven't brought my two-node workload cluster because we're going to build new workloads completely on the NetApp HCI. But it is brownfield environment. Yes. We did have some challenges on Monday afternoon and Tuesday getting the network configured to mirror how I normally set up my networking. So as usual, if there's going to be a problem, it's the network. And as we work through those issues, we've got things resolved out. Now, there was a phone call that we didn't actually have, but should have had before we turned up on site, where you do the discovery. So this is the way the normal engagement it flows with real customers, is you do a phone call or a site visit beforehand and gather some information. Can you talk us through a little bit how that process works?
Yeah, so the way that we do deployments is exactly what you're talking about, having that pre-prep meeting to go over the networking. And the way that I position that is to really have that done before we even schedule an installation. Because if we are using the customer networks, it's on that call that we give them, and we'll be going through the guide that we hand out, but we're going to ask for what networks we require, what VLANs we need, so that they know exactly the physical cabling as well as the logical cable networking requirements that we have with our NetApp HCI. Even if we are using our own provided switches, because we do offer switches as well, and in that case, our team is going to be doing the build out of the switching environment for HCI. But we still want that prep call ahead of time, have all of that laid out so that they understand how we're going to handle uplinks into their environment and truly understand what we're going to use, how we're going to design that cluster and get that networking information.
And then the result of that call is this Excel spreadsheet that I've actually got open in LibreOffice here, where there's a whole checklist of things to look at as you're validating. Presumably during that call, you're sitting there filling this out, making sure that the data is collected, that we've checked all the right things, and that you've moved on then to the installation details page, where we can actually start to see how everything is going to be configured for the customer. And as we roll down through this spreadsheet, we get into some of the really significant details, like how the cabling is going to be configured. And we'll talk a little bit later, while we're waiting for things to deploy, about how you might build that cabling out.
Yes.
But importantly, in here, we go through the number of ports that are required, both 10 gig and 1 gig, and what sort of transceivers you're using. All of that kind of information is gathered in here, along with the whole stack of networking information. So this is the one central place that you hand this over to the customers at the end as part of their delivery documentation?
Yes, we do. And one of the things, though, is before I send this out, that's going to be that prep call, because you look at this sheet and there's a lot of data on it, but we've actually automated most of it. So there's only a handful of fields that we actually have to fill out, and it will auto build out IP ranges. So for instance, for here, we just gave the first network IP, and the rest of it, the naming conventions, all of the IP blocks, were filled out automatically for you.
And I kind of struggle with this, because I come from a traditional background where you want matching IP addresses for resources of the same type, and I have this whole beautiful layout that I'm realizing is completely wrong, because I should be just trusting the system to build it for me and using these automations. I need to shift the way I approach using these resources, and we'll see, particularly as we get into the Kubernetes deployment on top of the getting used to cloud native, where things have indecipherable names, because you don't care in particular. You care that the service is being delivered more than anything else.
Correct. Yes, and we do give our customers that option. So we have this auto, fill in the different ranges, but if you want to change it, and we'll actually be going through that. So we're going to change at least one of the IPs as part of the deployment to show that flexibility.
What else have we got through here in the documentation? Very much the necessary documentation as you're deploying out new infrastructure. All the networking, all of the IPs in here. All right, so if we've got all of our documentation about what we're going to build, there's also this deployment guide here that we have. Now, we were discussing before that normally the deployment is a white glove service from your local. Would it be a NetApp SE, or would it normally be a partner SE who would come and do this deployment?
We have it in both cases. There's a lot of them. We do have partners trained that are comfortable and are doing their own implementations. We have a lot of customers that actually have our HCI in their labs. So they're developing their engineering resources around it, deployment services, and other services to layer on top. We also do leverage our own professional services team to do these white glove deployments, and we see those going on all the time. We try to always, like you mentioned, the white glove treatment is something that we always want to be part of to make sure that we have that not only a consistent setup, but it's going to be reliable and we'll get the customers up and running.
And then continue to support them through the life of the deployment.
Correct.
And so this deployment guide that we're not actually going to need to read extensively, but I imagine it's the core to people building additional services around this is thinking through the deployment processes. And as usual, I'm going to follow my methodology of reading the documentation if and only if all else fails.
Yes.
And this is also why I have a Kevin beside me to look at how I'm getting things wrong if it goes wrong.
Definitely.
Because that's certainly what we found yesterday as we were getting the Kubernetes piece up, there was a couple of faults in my infrastructure that caused the problems rather than being anything to do with the NetApp products. Which, as a customer, is disappointing because I like my infrastructure to be nicely built, but from the point of view of doing this event with NetApp, it was good that it was my stuff that broke.
Yes, what we've seen is once we have that networking consistent, we have, when networking is correct, we have a consistent, repeatable process with NetApp HCI implementations. Once we have that piece, and that's one of the other reasons I see a lot of our customers. We have customers, whether it's in mining industry or pharmaceutical industry, that you don't have this extensive IT staff in all your locations. And going with NetApp HCI, you can have that consistent setup no matter where you're delivering it and who's going to be doing the implementation.
I think that was hearing during the week about just how insanely powerful some of these HCI nodes are, and I can see them going into places where you need a lot of compute, but you're not necessarily got a lot of routine staff there in the oil and gas exploration. Presumably there's quite a lot of places where it's deployed out to give extreme compute power, but with no local management for it.
That is correct, yes. We have a lot of that, especially when we start talking about end-user computing or looking at just VDI in general, as well as what we're doing now with our new NVIDIA processing nodes. We have both our M10s and T4 nodes that can deliver both VDI as well as the latest node that's coming out to do inference as well.
So actually doing the machine learning element all inside this HCI platform.
Yes.
Nice. Well, we should build an HCI platform.
Sounds great.
I remember we were going to go to a initial launch point off one of your pre-built nodes. So we built the IPMI configuration. There's nothing special about setting up IPMI configuration, but you factory reset the nodes. Apart from you set a static IP address on one.
That is correct. So, what we are using is we're using a private IP addressing scheme. So you're not having to log into all nodes. So like we mentioned that we are starting with 4 storage nodes and 2 compute. So instead of having to log into all 6, it's actually just 1. We assigned 1 temporary IP, which we, ending in 199 for the network. And so we'll launch that and kick off the deployment from there.
Okay. So it's on my management network of 192.168.199.199. And this is where we find out whether you rebuilt it exactly the same today as you did the previous day. Now we're a little concerned at the time.
Yeah, and if this doesn't launch, we'll just pull it up into. Okay, so what we'll do is we'll log into the IPMI and just double check.
So looking at the spreadsheet, this was going to be the first of the storage nodes. This one here. This GG1 was the one used. So there's our IPMI address. Do that. This is the way we show you it's for real, that we're having a problem at the initial deployment. Let me take another tab and go to there. Well, at least there's something there. It's much more reassuring.
And this will be admin and admin, all capital actually, for both of them.
That's the default.
Yes, it is.
It is the default for the vendor of this hardware.
So we'll go to remote control, we'll go to IKVM, and we'll launch that there. Okay, so what I did here is I looked at this, and this is kind of showing that TUI interface that has the auto IPing. So just hit N. So when I was building this out, just resetting things up, I actually, one of my mistakes here is I didn't actually put it on 1. So we'll look at another node here to make sure that it has, so we'll just kind of go down the line. And this shows that screen. So this is all, nothing really filled out here. If you go all the way to the bottom, we did actually, just keep scrolling down with your mouse. One of the things we did do here is we can see that private IP address, and then we set up, we just enabled it to have LACP. So let's go into 215.
That one.
Okay, let's check the next. So we're just kind of, this is again my.
There's also DHCP on the bond.
Okay, and this is actually what I was doing. This is, make sure that we have that DHCP on and, enable LACP. So that is one of the, the first things that I do as part of a deployment.
I presume we want to look at 216 and see if that's got the static IP address on it.
Okay, and then let's just look at 217.
So you're expecting the static IP address to be on the 1 gig?
Yes, and if it's not there, then I might have forgot to do it. So we'll just put it in now.
Oops.
Last node.
Because you were not able to ping. We could try a ping, but.
So Kevin has been working really hard the last few days to get everything to work. So yep, it looks like you just missed one step late last night as you were doing the second reset of the day.
Yes, I did. But as we are doing a full build out, this is actually the first step you would do as part of a deployment. So what I'll actually have you do is just go down to IPv4, and we'll hit enter, and now type the IP.
168.199.199.
And then hit enter.
And then subnet mask as well.
255.255.255.0. And then I added the gateway, just being .2.
Which will be very familiar to anybody who works with AutoLab. It's the same standard management network for AutoLab.
All right, and then hit S to save it.
Yes to accept the changes.
And now we will try to log into that node.
Wait for that to complete. Assumably there's some services restarting in the background. There we go, static address has been accepted. We'll go back here to our 199 and do a refresh on that. Oh, lo and behold, we got a nice wizard to start with.
Okay.
So I'll just follow along the wizard and get started. Switch to HTTPS. Have I read the deployment requirements?
That is the deployment guide we had up already today.
Excellent. Powered up the network. Yes, I'm authorized.
Yes, so as we are deploying both our nodes as well as VMware, we have both license agreements as part of this.
I'll read the NetApp license agreement very carefully. Yeah, yeah, I accept that. VMware license agreement, you know, I've read this one before. I think it's the same version. I'll accept that one too. And then we'll continue.
And right here, one of the things we have is we're looking at the configuration. So we have both the option of deploying a new cluster. So this would be, you know, greenfield environments. You want to bring that in, deploy it. We've had a lot of customers in the past do that as well. What we're doing here, though, is, as you mentioned, you already have a vCenter built out. It already has your compute nodes. Instead of trying, you know, building our own cluster and moving things over, we'll actually be doing the join and just join this directly to your cluster that you have already.
All right, so I will enter my normal VC Virtual Center DNS name, then the DNS server, which of course is the domain controller, and then a username on vSphere. It's going to be administrator at vSphere.local, and that password for the account. It's a freshly deployed vCenter appliance at 6.7 update 3, which we should be able to talk to. And now I need some credentials for the storage cluster and management.
Yeah, so what we had in that deployment, guys, we're going to use administrator here. And then we just have a couple password requirements that we have to. And before we were just doing it all lowercase.
Were just my reflex of putting a capital A on administrator. We'll use that password and we'll use it again just to confirm. Good. Reasonable complex password requirements.
And so now what it's going to do is it's pulling up our network topology. So we have two different options here in terms of how we can do the cabling. So we can do a 6-cable configuration, which allows customers that don't want to be using VLANs to have everything separate. So it's going to have management on 1 gig, it has, and then different port groups for iSCSI, then the VM networks. Instead, what we've done here, and we've cabled our system up for a 2-cable configuration. And one of the things there we did is, you know, and we mentioned network issues, and how we started this is, you know, when we had that prep call and we discussed it, we just, you know, this is a new cluster. This is a customer build out. So, you know, I pulled all the cables and we started all over. Followed that deployment guide, which actually we'll go through, but it shows network configuration. And we followed that guide to how to cable it and set it up.
It all came through nicely. And so we're using on the compute nodes just the 2 10 gig networks, and everything is converged onto those 2 10 gig networks, although there are 2 more SFP plus ports available.
That is correct. And we do support customers adding onto those later. So if you wanted to, you know, enable those after the fact, we can certainly do that.
And if I remember rightly, the compute nodes also have an empty PCI Express slot. So if you need even more networking, that would be an option to upgrade as well, although that would limit your ability to use a GPU in the compute node.
Yeah, and you know, depending on the version that we're at, we do allow certain, you know, how we can expand out clusters in that.
And we'll show you very shortly the unboxing video so you get to see the actual hardware. And then there's only a 4-cable option for the storage nodes.
Yeah, so today what we're doing with the storage nodes, and you know, when we even look at the compute nodes, so it shows 2 cables here. We actually have a 3rd cable plugged in. The 3rd cable is for lights out management. On the storage nodes, we do require 4 today. So we're keeping the management on a 1 gig network, and then we're doing all of the iSCSI traffic onto the 2 SFP plus or SFP 28. We can actually do both 10 or 25 gig Ethernet on it.
And separating out that storage network allows me to have a non-routable storage network, which is always preferable, and do management on a separate network. There's some IP-based storage solutions that require routing between for management, which it's a debatable, but there's certainly a historic preference for having an isolated storage network.
Yes, and then this also allows us, you know, I mentioned that 3rd cable for, you know, lights out management on the compute node. Well, on the storage, and most of my customers just have it in failback mode. So it's 4 cables total, and it's doing both the management traffic as well as the lights out management.
Right,
VLAN
it's
as
all
well.
shared.
Yes.
And that suits really well if you've got that all on the same VLAN. Okay, we'll continue on with that and see what we get to see. Now this is the point where my passing comment to you about powering off the additional nodes that we're going to use to expand will come in, and we'll see whether it registered with you late last night as well.
That I did not end up powering them off, so it is still in here, but we can, what we'll actually see here is the other thing with NetApp HCI is we allow mixed clusters. So, whether you start with a certain drive size or a certain node generation, we actually allow for intermixing, and we've done that here. So we're using, different size of nodes that we will be adding to the cluster than what we've started with.
So we're starting with these 2 compute nodes that both have 8 cores and both have 384 gigabytes of RAM. So they're moderate configuration. These will be your scale out kind of configurations.
Yes.
And then the storage nodes, we've got one that we must use. That's the one that we're currently connected to. And then what else? We've got 3 more that are in the same enclosure, but we have another one that's in a different enclosure.
Correct. So we actually started with 2 enclosures, and from this original deployment, we had the storage nodes in one, we had compute in the other, and then as we went to scale it out, there were 2 empty chassis, 2 empty slots within the one that we had 2 compute nodes. So we ended up adding a compute node into it and a storage node.
So the actual enclosure isn't specific to being compute or storage, it's the node itself that is specific.
That is correct.
Excellent. And I guess you'd quite like if there was a 6 sled enclosure that was 3U high, where you could have the entire initial configuration inside one enclosure. At least customers might like that idea.
Well, what do we actually do with the cluster? And part of our flexibility is, so we're starting out with these 2. So let's say if I knew that you were going to start with, go to 3, I'd actually, put 2 storage nodes in each. And then when you add that third, let's say you add 2 more storage nodes, what it's going to enable by default is actually chassis protection. So we have protection domains. You don't have to click anything. It's going to start redistributing your data and have that chassis level protection as well. So just another safeguard as part of our data protection.
So if you were doing this for real with a customer, each of those 2 enclosures would have 2 storage nodes and 1 compute node.
Correct.
Just not the way it's laid out in this particular case, although again, it's my preference for things looking pretty is getting in the way of things being really functional.
Correct. And we are flexible, like you mentioned. It doesn't matter what slots. So we make our recommendations, and either way will work. So.
Okay. Now we've got our DNS taken from the configuration I already provided. Took a default NTP. Time sync is always important. And then there's a few settings down here that need to be configured.
That is correct. And this is actually filled out just like it looks in that HCI installation deployment guide, or the template, the Excel-based spreadsheet that we were looking at earlier. And so you could follow that and enter everything. But one of the biggest challenges there is it's humans, right? And the accuracy of typing things, and did we type the right IPs and where? So we've actually developed, and we'll use it here, is launch the easy form. And we've added a tab, and right into that same spreadsheet that we can look at that will show what to fill out in here.
So if I go back into that spreadsheet, there is the easy form view. So here's the answers to the questions in the short version of the wizard.
That is correct. Now, one difference with this is it shows vCenter as we're doing a join. We won't see that in the actual.
We're not configuring a new vCenter, so we don't need the settings for that new vCenter. So let's pop back into the easy form. What did we decide we were going to call these?
We named this BDL for Build Day Live -NetApp HCI.
We're going to get the product name nicely placed. All right, next things we want to do. We do want to use VLANs. We like VLANs. Management, compute management, all of the management is using untagged, so we won't put a VLAN ID on those.
That is correct.
vMotion is always on VLAN 16, where Autolab's using VLANs, and iSCSI on 17. So the thing that confused me when I first looked at this is I expect to go across and then down, but you go down and then across, because when we hit next in here, all of the other fields open up for me.
That is correct. So we start with here, and at this point now we start filling it in, and it actually will auto fill out for you a lot of the other fields. So, even though this is the easy form to fill out the rest, it does, you saw it just fill in the rest of the subnets across the different networks as well.
And it corrected for my typo there. We want 192.168. Now, management node, what's this fellow?
Yes, it was.
What is the management node that we're deploying here?
So what the management node is going to be is it will be a VM as part of the deployment, and that is going to be used for upgrading the system as well as providing access into NetApp ActiveIQ support. So not only will that be for proactive support cases and case management, but we also use that portal to send statistics up so that you can we collect up to 5 years of historical monitoring of your system that you can look at then from ActiveIQ to look at what's going on in the system. Forecasting
and performance review and that kind of thing through ActiveIQ.
Yes, it does, and it will show you forecasting about. We built in our own intelligence to realize, based on your growth patterns, how long do you have before you'll run out of disk capacity, storage capacity on that cluster.
Does that look also at scaling of performance, or we don't see that as being a common problem for customers with this platform?
Yeah, on the performance side, because of our scale-out architecture, every time we're adding nodes, we're adding performance as well, and we're adding that storage side, and actually compute as well. It's bringing in its own compute performance. But yeah, we tend not to have that issue, but we do show that as well.
Sure. So it's filled out all of my compute and storage management addresses in here.
Let's just double check, because just to make sure that matches up. So we're actually, because that started at 9, by default it actually started the next one at 10, but we're using 10 for one of your servers, so we're gonna take that next one and make it 11.
And now we've got an overlap because compute management is going to use 12 as well, so we need to have storage management go to 13. So internal validation going on all the way through. Set up the subnet for vMotion, no default gateway, 16.199. What did we have for start there? 11 for that start. And then storage. This is the standard IP storage network inside Autolab or inside the customer.
We started at a 10 there. Let's double check.
We've got 13 in here.
We're on the iSCSI network actually. Right
we're
now.
down there. Yeah, I'm looking at the wrong place. You are absolutely. I'm glad you're here saving me from myself.
That is why I like that easy form too. Makes it simple.
We'll apply the network settings. So it's now filling out that form we saw before and immediately going on to validating the IPs. That's nice.
Yeah, so we're going to be looking for any IP conflicts or anything else within the system. So we're doing that now. And right now all these fields are grayed out. So that will open up when the validation is done, and then we'll make one of the IP switches, or we were going to make one of the changes.
Do a manual edit.
Yeah, so what we're doing now is we've moved our management node over to container services. And based on containers being ephemeral, we've introduced our Trident plugin. So we're doing persistent volumes off of the cluster with it. So we've now introduced both having access to the storage network as well as the management network on that management node. So what we'll do then is, it auto-filled out one of the IPs that we just want to, based on your best practices and how you keep your environment, we're just going to change one of the IPs up one number.
So that wizard lets us create something that's nice and programmatically and internally consistent. But here, as a customer, I can override and say, well, actually, I want it slightly different because I have an unusual standard in my organization, which is what we'll do.
Yes.
The sheet. And all this information, where it's just going to be stored in that spreadsheet and nowhere else, correct?
For the information, yes, we're storing it in that spreadsheet, and for what we did for a pre-installation, we stored it all in that spreadsheet. For both your access, and we like to get that, the information over to our support organization as well, so that they kind of understand what the deployment looked like up front, and how it was deployed, and if we have an expansion, that we have those resources as well.
So that's the documentation that the support team are going to have, that you're going to deliver to the customer as part of the end of the project. But then the customer's probably got their own IP address management tool that they're going to fit this all into as well.
Correct.
There we go. We are successful with that network configuration. We were back at that management node, wasn't it, that I wanted to change the IP address of?
Yes, it was, and it's right here.
Yeah.
So what this did is, based on that auto IP addressing, is it put your storage iSCSI IP at 10, and we just wanted to keep it consistent with what the management is. So
Yeah, the last octet of management is 9.
And now it will, we'll see that green checkbox, so there's no IP conflict there, and we can now continue.
Ding. Continue. So we've got a whole lot of, this is what we're going to do, summary of activities.
Correct. And there is a button at the top right that you can export this information out, but after you press submit and we start the configuration, you're not lost there. You can actually still download it after the fact as well.
Great. Well, let's start deploying. And I will follow the instructions, because we're looking at the management interface currently through one of the nodes, and that node's IP address is going to change, so we'll copy that. And we will just pop that into another browser tab now. And it won't come up yet because the IP address hasn't changed. So we'll go OK on here. And then the wizard goes, and how long is this going to take?
In a new deployment, it takes about 45 minutes, and that consists of adding in, setting up the ESX. So we will actually, what we've done here is we've given options. If we didn't do a new vCenter build out, but if we did, we'd have the option of using 6.7 or 6.5. So we have both of those images on each compute node. And so what we'll do here is we first validate all that deployment data, we create the networks, and then we start installing what you picked for the ESX version. So it will install ESX on those compute nodes. And then once it's done with that, in our case though, since we're doing a build, it's going to join your cluster. So the order of events will be create that storage cluster, install ESX, integrate all this into vCenter, and then create that management node. And one of the checkboxes that was on the last page at the way bottom was, do you want to report this to ActiveIQ? And it's checked by default. And so what that does for us is it sets up the connection right to ActiveIQ to have that remote monitoring set up for your cluster.
I like remote monitoring. I like to have something smart that's going to particularly look across data with multiple customers and start seeing trends across customers and letting me know how that affects my environment. It's one of the great values of having a management service that runs as a service in the cloud somewhere for me.
Yes.
We didn't even need to copy that URL to the clipboard because the web page just redirected. And while you were watching the unboxing video, the web page switched from being the temporary IP address to being the permanent IP address of that node, and here we are with the progress in the cluster. And interestingly, there's lots of detail about what's been completed, all of the steps that are done, and that's always nice to see. And we can see the progress of where we're at. So the actual ESXi deploy is happening at this point on those compute nodes. So while that's still progressing, and we can see overall progress is just over 50%, so I think we're going to beat your 45-minute estimate.
Yes.
We always like it when it's a little bit quicker, but of course completely hands-off, so we could be going out having a nice lunch while this is going on, or more likely dealing with some help desk calls.
Well, it is nice around here to go get lunch.
It is. We've had some beautiful lunches here in downtown Boulder and surrounding areas. Best meal of all, of course, was directly upstairs from the office here. Outstanding steakhouse upstairs with wonderful views up into the hills. But most places that we're doing this don't have nearly such nice facilities, so we shouldn't make our audience too jealous.
We're outside of San Jose for this build day. So if you haven't been to Boulder, Colorado, Come and see the Mork and Mindy house. Come and see the just the downtown end. It's awesome. So.
But I did want to have a look a little bit more at the networking options and configuration options and see what we've actually got there. So you gave me this diagram of what the back of the rack looks like with the switches, and because we're using your switches, my normal build day live switches just don't have enough 10 gig ports for four storage nodes and 2 compute nodes, let alone the expansion we're going to do. So we're using these 2 switches that you provided with us that is an option for customers. Can you talk us through a little bit what we have configured on there and how this all looks?
Yeah, so what we've done here, and was plumbed all the networking up. Actually, I mentioned this earlier, but we did it based off of a diagram that we'll see in the deployment guide, the same installation document that we sent to our customers to fill out. And so what this now looks like is we have different colors, and I labeled them here. And these are 25 gig switches, but in certain environments we may want this isolated, especially if we're bringing it to a remote site. That in some cases they say we only have 1 gig today. Well, we can bring these switches in. That's a perfect example. Bring it right in with the solution, and we can actually use all of the networking right directly on that, which is what we did here. So what we have is we have the 5 storage nodes, and as we see on these switches, is each storage node had those 2 connections, 2 1 gig, and we can see that on the left in yellow. The storage nodes also had the 2 10 gig, and what we've done here is we're actually using the breakout cables. So there's 400 gig ports on each of these switches, so we use 2 of them for the ISLs in between, so we're connecting the 2 switches with those, and the other 2 ports we are using breakout cables. So that breaks out to both compute and storage nodes, and that's providing those services.
So you're using fewer physical ports on the switch in order to get all of that high bandwidth connectivity to the nodes. And it's not clear on the diagram. The storage nodes are labeled up here as in blue as storage 1, 2, 3, 4, and 5, and the compute nodes have the purple labels on the nodes.
Yeah, and certainly in a rack, those labels aren't going to be there. The easiest way, if you're a customer, to kind of look at this system and be like, which one's which, is when we look at this right now on these, the storage nodes have 2 10 gig, 10 25 gig ports, and the compute nodes have 4. So that's
we saw that in the unboxing video with Rafael.
All right.
So that was the easy way to identify from the back. Once you've got them out and on the bench, you can see the cache module, the vBrownBag cache module in the storage nodes that's not present in the compute. So there's a couple of tells on which is which.
Yes. And then with this setup, what we've done is we have 2 green ports that are saying that are uplinks. So when we talk about what we require from your networking and your switches, is we just took 2 ports. So we uplinked from our switches here into your network. And that configuration was automated as well. So in my side, run the script that we provided, or run the commands that we provided, and it built out the switch with those uplinks ready to go.
So that the actual switch config was written by that spreadsheet, so long as you were running it in Excel. I'm running it in LibreOffice, so the automation probably won't work in there. But back in that config spreadsheet, there was a switch configuration page.
So this switch configuration page is what we'd actually look at next. So you first need to pick out what number, but if you go to the top of this page, and we'll see if your application, it doesn't look like it did because it's got config 5 selected there. What it would be doing if it had that automation in place is if you change it to config 4, for instance, is it would start filling out, actually it may have here. The only thing, it would start filling out some of the additional information. I think this may be just because I put in the checklist, we may have selected no on an option. So.
I think it's to do with how I opened it in LibreOffice, that I wasn't confident that the automation that runs so nicely in Excel would run it all and not make a mess of everything in LibreOffice.
And then what we have on the config planner tab is there's options of how you want to cable it. So if you're a customer that's, that top one there would say, hey, I'm not going to use your 25 gig switches to give me 1 gig connections. I have my own 1 gig switches for that, so I'll just use my management. And we're doing 2 cable. And what this switch will build out is it has all these ports, so it'll build out that config up front. Even though we're only using 5 storage nodes and we're going to scale up to 3 compute nodes, it still has in here, having that, and I don't know what the number is, but like 12 compute nodes and 12 storage nodes. So that if you go to scale that 6 node, you just plug it right in.
Right.
Networking's ready to go.
Configuration's already ready, because of course network configuration changes are very tightly controlled and problematic at times.
Yes. And there's a plus box right on that left-hand side. And since we're just looking at one here, we can hit that. And this is what I mentioned about a switch configuration.
Let me move through this a little more slowly so it's visible on the screen.
So what this has done here, and there's even instructions on how to use this and how to deploy with it right on the top, is essentially what we want is we put that purple section there. So we're going to have you cut and paste those commands first. After that, cut and paste the rest of it, and it builds out your switch for you.
So the whole switch config, now this is for the Mellanox switches that you sell. That presumably this configuration builder is specific to the Mellanox switches.
That is correct. Now, when, and a lot of our customers are using Cisco switching, it is a standard, and when we do that, our professional services guys have examples. So we provide those examples of how we want the switch ports configured, just so that, in case we're not working with a network team, in a lot of these cases, we may be working with a virtualization and a storage architect as part of that deployment, and we can at least give them what they're going to ask their network team for.
And hopefully in nice clear language the networks team understand, because often there is a mismatch between understandings there.
Correct. And as we're doing the 2 cable, it's basic network configuration that we're asking for, but on the storage nodes, we showed when we launched that IPMI screen, we set it up for LACP on the storage nodes. So it's important to know what ports you're plugging into those to enable that the link aggregation.
Yeah.
And then on the compute nodes, as we mentioned, 2 cables is sharing multiple networks. So it's really just making sure we hit all of those different VLANs.
Nice. Nice, and that just gives us nice consistency using these pre-baked scripts in here as well. All right, let's take a look and see how far through the deploy progress we are. Well, we're still at 80%. We're configuring the management node now. It's going to take a little while to do. What we should see in vCenter is there's been some progress. So we actually have our NetApp HCI data center and cluster here, and our compute nodes are in, and our management nodes being deployed on top of them. So we're seeing good, steady progress. But it looks like we've still got a few minutes to run. And wouldn't you know, the wizard has only got to 97% as we've played out those videos. So let's take a look at how things are progressing. So it's just configuring the management node properties at the moment. So we do still see in vSphere our hosts. We've got a health issue. What's our Amber sitting here? So we have the TLB CPU issue present on these nodes. Normally you'd apply a hotfix or disable some features. We're just going to suppress the warnings in here around that CVE issue that we're familiar with. And then at the moment, we haven't yet got our heartbeat data stores for vSphere HA. So HA has been automatically configured on the cluster, and it's just waiting until it's completely happy with that. Let's just see how, there we go. We are complete with the installation. Progress is all done. So that's nice. And up the top, it says, go start using.
Yes, so at the top here, what we have on the left-hand side is to launch our application to upgrade. So what this is for is our hybrid cloud control services. So we'll launch this, and SSL certificate showing up here. So let's just wait a minute for that to
wait the 10 seconds for it to redirect to a secure. And this is that username and password that I just set in the wizard for the management, for the NetApp HCI management node.
That is correct.
So that was administrator and that password.
So what this has here is we can, upgrade an installation. So that would be, we can click on that now, and with this latest build, it's already there. But if there was an upgrade, you'd press begin upgrade, and it would pull that in and automatically upgrade the management services to our latest hybrid cloud control services that we have to offer.
Right. So nicely built into the product to do the upgrade. And later on, we'll enable this NetApp Cloud service of the NetApp Kubernetes Service. And we'll look at expanding as well, although we won't use this interface to do the expansion.
Yeah, and what this interface does is we see it right now because we just launched it, and we have the expand button, which we could bookmark, but there's also a way to get to it right from the vCenter plugin. So within vSphere, we can go to our NetApp HCI plugin when it pops in. So it's going to, we will have to log out and log back in to get that to show up. And, what we should see is a blue bar pop up at the top that kind of says, hey, you have a new plugin to enable, and we will relaunch it with that when that comes in.
So let's log back in as administrator at vSphere.local. Log back in, it should rescan at this point for the plugins. That's going to be a warning about using expiring licenses. Let's now run the deploy plugin. We can see the deploy plugin process has run. We refresh the browser to start using the NetApp Element plugin.
Yeah, and so what we do deploy with temporary licenses for ESX. NetApp is not providing permanent licenses for customers, so they bring their own licenses and can apply it later.
And it's just, as we take a look at the ESX server itself, it's, in this case, 6.7 deployed out and updated and managed as normal as a vSphere server.
That is correct. We keep it consistent with how customers are used to upgrading their VMware environments. So they can use VMware Update Manager to update the compute nodes to the latest versions and look at it that way.
Great. And we can see in there the capacity. We can see some storage capacity. So there's 4 terabytes of storage available. Looking at that as our data stores, we should see that, there's some local storage inside the node, a very small amount of that, 216 gigs of local storage. That'll be the boot volume. And then we have 2 NetApp HCI data stores, which are coming off that storage cluster. Nice and easy. Not a huge amount of capacity in there because this isn't really for deploying out of a customer's production environment. If it was production environment, there'd be more storage in each of those compute nodes.
Yes, and what we do though is we auto deployed 2 data stores as part of the deployment. We're putting our management node on one of those. We're putting, if it was a new deployment, it would put vCenter on there as well. And then from there, you can certainly scale it out. There's a lot of automation built into this platform, so we can automate however many data stores you want to put in, or we can go through our management plugin for that.
We got 2 people in the chat already. Feel free to go over to youtube.com/redirection to talk with us. Joseph Zoda said it's perfect for us. They got the purchase approval for 2 HCI chassis with 4x compute nodes, 40 core, 768 gigabyte of RAM, and 4 storage nodes. And then Franklin Santelope says, nice setup. You're going to have a lot of fun with that. If you're using Kubernetes, check out the NKS Cloud enablement functionality. It's super slick and real.
We are definitely going to be doing the NKS deployment. That will be our last big piece of the Build Day Live event today, and I think it's pretty cool.
Yes, I agree. I've done a lot with NKS and Kubernetes over the last couple of years, and not the NKS side to start because it wasn't,
it didn't exist 2 years ago.
It didn't exist, at least for NetApp side of things. NetApp purchased StackPoint just recently and integrated that whole platform right away. And so now we do, as mentioned in the chat, it's bringing those hybrid cloud control services right into our on-premises NetApp HCI to really deliver a private cloud delivering Kubernetes services.
It's as if we'd thought about this before. So now that we have our cluster deployed out with our 4 compute nodes and 4 storage nodes and 2 compute nodes, we wanted to show the scalability, because this is one of the differentiating features of the NetApp HCI solution. Where am I going to go? How am I going to go about doing that expansion?
So let's start by going to the plugin. So I'll show you what we deploy. So let's go to menu here. And we'll start out with the NetApp element configuration. So this does allow you to have multiple clusters in here. So it does have that getting started, but let's go to clusters and we'll see that we have. So we only have 1 cluster that we've built out. It's our 4-node cluster. And we can see this here. If you ever needed to or wanted to go directly to a storage UI, that's a good, and you don't want to pull up your spreadsheet, it shows it right here. And, as you just showed here, you have that option to expand in this right here as well, to expand NetApp HCI. So there's a couple of different places that you can do that. We saw that screen right after the deployment engine finished, that it said, do you want to expand? We see it right here. And then we also have it into the management side. So one of the other features that popped up was encryption at rest. So by default, we did not enable it, but it's all of the drives in this platform. We do sell non-encrypting drives for countries that may not be able to accept them. But in this case, they're self-encrypting drives, so there's no performance loss. We can just enable that feature right on the cluster.
And that was on all of the storage nodes we have, since they're presumably US destination for all of those.
Yes.
So we have again a getting started page here for the managing the cluster. So from here we could create additional data stores and expand.
That is correct.
What else have we got in here? So we have the ability to see all of the objects, so data stores and volumes and
it is all
details of our cluster.
Yes, if you needed to add another data store, you're not creating all of the provisioning yourself. It does launch a wizard to create that data store and which size you want to make it, and it provisions it across the different nodes within your cluster.
And we can see all the way down to the individual drives in all of the storage nodes in here as well, which is nice.
Yeah, so what we have here, and we're going to do a storage node expansion as well as a compute node, but we can also scale back. So when we look at here, it's an exact opposite process. So if we were going to scale back, we would go on this page here and we could select the drives for that node, remove the drives from the cluster. Once it's done syncing, remove the node. And at that point, it's safe to, instead of just pulling it, which we could do, but we prefer doing this way.
Do the protection on the remaining nodes rather than having it compromise the protection by just pulling the storage node out and have the cluster rebuild afterwards.
Yes.
Yeah, let's protect our data. It's job number 1 for any storage system.
Yes, but I've had a lot of customers that buy NetApp HCI. They may start with 2 of the exact same configurations. And what often happens, though, is one site is growing at a faster rate than another, or whether it's 2 sites, 5 sites, or any number of sites. What they're able to do with this is remove those nodes that are in an existing cluster, not a 4-node. We want a minimum of 4. So if we're in an 8-node cluster, for instance, we can go remove a node and go ship it to another data center.
And that scale in is usually much harder than scale out. Scale out is a much more routine activity, but scale in is crucial in some use cases. You don't want to have that older storage characteristic where you can add to the bucket of storage, but you can never remove. That ability is pretty cool.
Yeah, and another customer I have was, had one of our original element clusters, and they went to refresh it with our latest nodes. And we got on the calls, just like we're doing here, to prep. How do we want to do this migration? What do you want to do? And what the use case here was, it's mostly VMware. So VMware, we can do storage vMotion and just create the new cluster as it is, and do that traditional, or even leverage our replication. So we have built-in replication to do it. For them, though, they have some direct attached older Windows hosts that they can't take that application downtime.
Right.
So instead of building out a new cluster, they just added the new storage nodes to their existing cluster And once it was all done syncing and ready to go, they ejected out the old ones one at a time. So a zero downtime migration for both the VMware hosts as well as the direct attached hosts into the cluster.
So you end up with the grandfather's axe of storage clusters, where everything underneath the cluster has been replaced at least once.
Yes.
And over time, multiple times.
Exactly.
Cool. And I've just been poking around pretty much at random here inside the management interface to see what we have. But we did come here to do the cluster expansion.
Yes, we did. And one question that comes up, especially having customers on and listening to this, is they look at this page here, and you're looking right in the middle, and we see node role, and we see that one of those nodes has an empty role. And really, there's nothing wrong with that. So in a 4-node cluster, we will always leverage 3 of the nodes for running our ensemble services as well as a cluster master service. Once you're at 5 or more, we'll always have 5. So once you have 6, you'll see an empty role again, but we'll kind of see that.
So this is the same behavior for any majority node clustering, that you want an odd number of nodes actually involved in that management cluster, in this case the ensemble nodes that are clustered together to provide high availability of management, and that if you lose one of those nodes, you've still got the majority remain. If you have 4 nodes, if you lose 1, a majority remains. If you lose 2, a majority remains. But you don't get any better resiliency than if you just had 3 nodes in that cluster.
Correct.
So this is why then, you had 6 nodes, you're still going to have 5. You always want an odd number in a majority node.
Yes, and so that's part of the ensemble services that I'm mentioning there. And then the other service is cluster master. So the cluster master is our entry point into the cluster. So as much as we filled out this IP spreadsheet and we made sure which node had the IPs, in most cases you're not really looking at it at that level because you have a single interface. If you were to provision out, we're starting this as NetApp HCI, but let's say you wanted to bring in a bare metal host. You don't need to know if we have 4 nodes or 8 nodes or what the IPs are. We're only looking at one IP, and we do redirects behind the scene from there.
So the configuration of the thing that's consuming the storage can be just to a single IP, and everything else is learnt from the cluster.
That is correct. Making it very easy for our customers to not only consume storage from a base setup, but be able to maintain that simplicity as they scale it out.
Right. Well, let's go through that, adding a node as we scale out a storage cluster.
Sounds great.
Where do I go?
So from this page, we'll actually just click on that Actions button. And I mentioned that expanding your cluster is in a couple different places here. So we'll click on that from this page here, which is launching our scale. So from here, we need to log in again, the same login and password. So we, part of that wizard, we made it consistent using the same login password across all of the different services. So first here, we're asking if you're going to add a compute node. Right now we're going to add the storage node first. We could actually do them both together if we wanted, but again, we're just going to do storage to start.
We particularly want to show that the ability to scale storage and compute independently.
Yes.
Okay, so no to adding compute nodes, and so now it just goes out and looks for available storage nodes. So this will be doing discovery on network, same as did in that initial wizard that we ran.
Correct. And where that initial configuration had these, again, it had that, if we saw it there, it had a 169 IP address that we didn't type in. It was automatically discovered. When we built out the cluster, that was all replaced. Well, we're still able to actually leverage that. So this node, if we launch that same IPMI out-of-band interface, we wouldn't see any IPs in it. Well, we would see the 169, but we didn't manually have to do anything.
Yeah.
Yes.
So if we select him, he's got 6 drives. Again, self-encrypting drives. 2 1 gigs, 2 10 gigs. Healthy networking. Everything is successful. Continue to him, and
One of the other things here is, we're showing the node type and raw capacity, and we showed, I believe you recalled, and I don't recall what the raw capacity was on each storage node from the original deployment. But this storage node that we're adding, actually the drive size is double what we had in the original deployment. And it's a different version. So, we saw H410 or H410 for a storage node, and now we're adding this H500 storage node. And so this is using 960 gig drives, where the original was using 480s. So what that's showing is our customers is the scale out simplicity is there, and customers want that, but you cannot have that architecture and then lock them into a drive size or generation, because if we're trying to transition people from a 3 to 5 year buy everything today that you need for growth to buy just in time for what you need when you need it, our architecture allows for that.
Or buy based on your budget cycles as well. What we find is customers haven't transitioned to a consume everything as they need it basis, but the flexibility to, as your budget cycle allows, maybe once a year you get budget to buy, maybe once every 2 years. No matter what, you can still add to the cluster. Are there any boundaries around how old of a cluster I could add new hardware to? Do I need to stay within a certain number of versions?
Well, so if we were adding a node to the cluster, we do, like part of the deployment, we do have automatic upgrades. We'll detect and upgrade the cluster. My preference is still just to do it up front. So I would at least make sure the node on the software level that we brought them both up to the same code revision. Now, in terms of generations, we've had a compatibility guarantee, so multiple generations that we can add within a cluster. So we still do have clusters with, I see customers with 3 different generations of nodes within the same cluster.
That's really flexible for customers. Just that requirement to be at a consistent level as you're bringing new in reduces the risk as you bring the new nodes in.
Yes, it does.
So we've got all of the same IP configuration to pop in here as well. So what have we got? We've got the SCSI VLAN is defined. We've got our default gateway for our management network. And then we just need to fill in the remaining host name and IP address in SCSI. Now, did we had that back here in our installation details, didn't we? Because we planned for this.
Correct. So you were right there, right at that last line.
The scroll on this laptop in RDP session and then to LibreOffice is fun. So there we go. That's my host name. Pop that in here. And then my management IP. And then I need my iSCSI IP out of the spreadsheet as well. And as soon as I entered that last IP address, it's going up, and I presume it's doing that network validation again, the same as it did when we entered the whole lot in the wizard.
Correct.
There we go. We'll continue on that. Yes, I do want to continue to use ActiveIQ. So I don't have to choose to turn on encryption at this point. So the note down here is data encryption will be available on the cluster afterwards. That's nice that it can be turned on afterwards if I chose, if I neglected to turn it on at the beginning.
Correct.
Presumably once it's turned on, you can't turn it off.
You can actually disable it as well.
Oh wow, that's a nice feature.
Yes, so it's, click it on, we can enable it. The drives are already encrypted, so it doesn't need to move anything around or cause that performance impact. It's just, we can enable it.
Cool. All right, and if I hit add notes, it's going to start the wizard. We'll give it a moment to bring up a status for us. But of course, it's going to move a whole bunch of data around, and that's going to take some time. There we go, as it starts the progress. If you're watching closely, you'll notice that Kevin is no longer sitting beside me. Joining me for this segment of the live stream is my friend Andy Banta. Andy, what's your role here? What's your title at NetApp?
Well, my title at NetApp is actually Storage Janitor. My role is actually VMware Integration Product Manager for the CIBU business unit. So for the NetApp HCI and SolidFire business unit.
And the storage janitor title suggests that you're cleaning up after a lot of things that have been done in the
I
past.
have spent most of my career cleaning up after storage messes.
Andy's history goes all the way back to the iSCSI stack in vSphere.
It actually goes all the way back to the fiber channel stack at Sun Microsystems.
There's a lot of history behind there, and this is why we particularly switched in some Andy, because he's going to share with us some deep insight into how things go. But Jeffrey, there's a question that came in as we were switched out.
So we had one comment from Tech Reckoning. He goes, very interested to see the NKS and how it's differentiated from the other cases. I'm guessing.
Kubernetes,
Yeah.
yes.
Nobody should be rolling in their own Kubernetes. That's an interesting one. Thank you, John. And then Joseph Zoda goes, for this install, he's asking, is encryption at rest a software option if the customer does not buy encrypted drives? So.
And the answer is no, it's not. So the only way that we actually offer encryption at rest is if you have SED drives. If you do not buy SED drives, we have no option to do encryption at rest.
You'd need to implement encryption at another layer. So you could use vSphere data store encryption.
Absolutely, you could, and that would actually give you the benefit of encryption at rest and encryption in flight. The disadvantage of using vSphere encryption would be that you've just negated the capability for us to do any deduplication,
any data
and
efficiency.
You've lost all the efficiencies that are available on the cluster.
So the short answer is if you have any thought that you might need encryption at rest, buy your NetApp HCI with self-encrypting disks.
Yes, and as far as I know, there's no price difference. It's one line item.
Yeah, so
Okay.
it would only be an export control issue
believe
that
that's-
would prevent.
I believe that's it. Talk to your salesman to make sure.
You know, it's interesting because Kevin did say that there were companies that, you know, overseas, they couldn't get encrypted drives. So what do you do in those cases?
We send them non-encrypted drives.
And that's all you can do.
That's
Yeah.
all we can do. Yes.
It's US export control.
Yeah. There's very strict export controls on secure technologies, and that's one of them.
Now, although our new additional node deploy has completed out, the reason we wanted to have Andy in is to talk about what actually happens during that cluster expansion, because when you're adding additional capacity to any kind of storage array, there's got to be some movement of data. It's a fairly intrusive thing, and Andy's the man for what goes on the inside.
Right.
of
So
that.
let's back up just a little bit and talk about how a SolidFire cluster works. So typically, in a minimal cluster, you'll have 4 nodes, and the way that we actually maintain the databases and maintain the data integrity on the cluster is we have a set of nodes that are known as ensemble nodes, which are basically the nodes that are allowed to vote on what happens to the cluster. This is always an odd number of nodes because there's no way that you can't allow a tie if you're trying to decide which way things should go. So in a 4-node cluster, you'll have 3 ensemble nodes. As soon as we went to a 5-node cluster, if you go take a look at the node list, you'll see that all 5 of them are ensemble nodes. So the way that we actually, so the maximum we'll ever have is 5 ensemble nodes. And so if you ever look at the list, you'll see that there's ensemble nodes and then things called cluster nodes, which are not voting members of the cluster. There's also something under the node list that would be called a cluster master. So what happens when you add a node, like you just did, is there's you added a management IP address and a storage IP address for that. You will never touch those IP addresses again. We have what's called a storage virtual IP address and a management virtual IP address. The cluster master owns these IP addresses at all times. So when you issue an API call or you use the UI, you're actually going to be talking to the management virtual IP address. So the way the storage works is iSCSI does what's called an iSCSI login. And so the iSCSI login is going to always be directed at the storage virtual IP address. And what happens on the cluster master node is that the iSCSI target on that node it will then say, no, I want you to temporarily reconnect to a different IP address. And that's where with the storage IP address that you used on that node will come in handy. So you will never actually have an iSCSI session that is established to the storage virtual IP address. It will always be established to the storage IP node, the storage IP address on the particular node.
And that's the iSCSI session redirection.
Yes.
That we see.
Yeah, so
Cool iSCSI feature.
Yeah, the important part of this is it's called a temporary redirection. So if for any reason we lose connection to that volume, that target, through that iSCSI connection, ESX or whoever is going to actually issue an iSCSI login back to the storage virtual IP address, and it will get redirected somewhere else. So the reasons this might happen would be that the underlying node has gone away. It failed for some reason. The more common reason is that the underlying volume has actually migrated to a different node. And this is exactly what happens when we add a new node to the storage. So we spread the volumes out across our nodes, across our cluster, by the size of the volumes and by the I/O requirements of the volumes. So we try to make sure that all of the volumes are evenly distributed across the nodes in terms of size and in terms of the IOPS that they need. So as soon as we added a new node, the ensemble nodes are going to start figuring out we need to actually migrate some data from one node to another. You never see any of this happen. It's entirely non-disruptive. There's nothing you have to kick off. There's nothing you have to start. And any volumes that are in use will get evenly distributed across those nodes, looking at both capacity and I/O requirements.
So the two data stores that we've got is a very small sample, but in a production environment, you might have 20 different iSCSI data stores on there. Initially, that'd be spread across the first 4 nodes, on average 4 data stores per node. It's how busy they are and how large.
Right.
But then silently, as I've added the 5th, they'll spread out again, and they'll be...
Right, and if you've actually set that one of them has higher I/O requirements than the others, that one might actually have a node all to itself, while others would gather on the other node. So it's also in terms of size. I mean, there's no way that you can actually have a large enough volume to consume all of the space on a particular node. But again, we will attempt to spread the size out. And part of the reason for this is how we actually handle recovery. So if for some reason a node fails or a drive fails, the whole idea of having a clustered arrangement is that all of the nodes work together to bring the system back up to a healthy state. And so the way that we actually do our data protection is if anything fails, we will have all of the other nodes in the system or all of the existing nodes in the system work to redistribute that data and have it back and protected as quickly as possible. So we don't ever think of ourselves in a degraded state, that we think of ourselves in a state of we actually need to rebuild if something has failed, and that's typically very short. So if we lose a drive, we typically try to recover from that in 8 minutes. If we lose a node, we typically try to recover from that in an hour. And we've done the mean time between failure math to trust that our data is protected.
And then, of course, in these kind of distributed scale-out systems, your resiliency comes back, and then you can have a second failure.
Exactly,
so
right.
Capacity willing, you can have further failures after that
Exactly.
time.
And if for some reason you've had enough failures or you've filled your cluster full enough that you don't actually have data protection, you'll get a big warning saying you need to add more storage to have your data adequately protected. We normally never want people to get into that state. I think Kevin might have actually talked about AIQ, which does phone home type reporting. So we will also get notification of that if you have it enabled.
So we'll get a phone call from the support team saying, hey, there's a problem that you...
Right, exactly. But the whole idea with the iSCSI redirection is the entire way that we handle scale out, our health, our health self-healing functions, our ability to do rolling upgrades. Anytime that you need to do one of these, you can simply have the volume migrated to a different node and have the iSCSI connection redirected to another node. And that way, you never lose access to it. So if we're doing a rolling upgrade, we will evacuate a node. All the volumes that were on that node will get distributed to the other nodes. We can go in and upgrade that node. And as soon as it's healthy again, we will say that it's healthy again. We have volumes come into that. And a couple minutes later, we'll evacuate the next node and start having start upgrading that node.
And if people are used to a dual controller environment where one controller owns a particular LUN and it has to be trespassed across onto the other controller, that's quite an intrusive thing and usually involves an interruption to IO performance.
Yeah, and iSCSI is designed to not do that. So the whole idea with the iSCSI redirection is it's a very fast transaction.
And completely routine. It's business as usual.
Completely routine, yes. So it should be several milliseconds of loss between an iSCSI log out and iSCSI log in.
Rather than 60 seconds that we sometimes see in
yes,
some storage
arrays. Or longer, yes. Yes. So were you going to show off the new node? Or?
Should we show off the new node? It has completed coming across, and we can take a look back in our element manager. And
well, here, if you actually have the node list, you should be able to see the ensemble nodes and the cluster nodes.
So we're still seeing 4 in there. Let me hit the refresh button and get it to reload the data. Let's just see if I switch to the drives view. It's not yet showing me my 5th storage node, but it's now reloading the node list. And now I do have 5 nodes, and we can see all 5 of them are now ensemble. As we saw immediately before we did the upgrade, we only had 3 ensemble nodes, and there were 2 that didn't have cluster nodes, cluster roles.
Right. Actually, there was only one that didn't have
there was
a
one
cluster
that didn't
node
at the time. Yeah.
You're right, and you can actually see the top one is the cluster master as well. So as well as being an ensemble node. So there's no distinction. Your cluster master does not need to be an ensemble node. They're 2 completely separate functions. Yes.
Cool. So we have plenty of expanded capacity in there. Things are all here and available to us.
Yes, the way it should be.
And we could provision more volumes out. We have enough storage for what we need for this.
Okay. If you want to go through the exercise, you can simply go into your vSphere client and say that you want to create a new data store.
So if I pop back into hosting clusters?
Yes. Yes.
And then on here, on configure. Yeah. And where are we? Storage. Add it in the data stores view. We can't add it in the data stores view.
Actually, you would need, if you go in through the vCenter plugin, you can say that you want to add a data store, and that will create the underlying volume as well.
So if we do it here in the element management,
yes,
back to where we were just a moment ago. If I do an actions in here, I'll create data store as its own button.
Okay. And we go ahead and create a data store, but it actually takes a couple minutes for it to be discovered because we actually have to create the LUN and then have to have it go be rescanned on the other side.
So because you rescan the other storage restate. Do I need to create a new volume, or am I using an existing?
You want to create a new volume.
Excellent. We'll do that.
And let's make it a terabyte.
And QoS policy in here. What have I got? QoS policies. Looks like there's no QoS policies here in this drop down.
Oh, well, you can create a custom policy.
Let's create a custom one then, shall we?
And you can just use that default policy that is set up for you.
Yeah, allowing us a reasonable amount of bandwidth. Authorization using the access group as the default.
Yes.
And then do I want to do SIOC, so doing some quality of service at the vSphere layer?
Right. In that case, you if you actually turn on SIOC on the vSphere side, what we actually do on the NetApp HCI storage side or the SolidFire side is that we will actually query those SIOC settings and set the QoS on the volume accordingly.
Nice. So I can then, on an ongoing basis, control through SIOC and have that policy applied back.
Yeah, and being the VMware guy, I would actually recommend that you use virtual volumes in that case instead of actually using SIOC, where you can set the individual IOPS for each individual volume.
Every single vVol.
Exactly, yes.
We'll finish out, and that new data store will provision up and be available shortly.
And I didn't mean to pull you off script, but
Oh,
If
off
you
script
were-
is always good.
Okay. I think we were also going to add another compute node as well.
Let's do that as well. Let's add ourselves another compute node. So we're going to do the cluster nodes, and we're going to expand again and then pop back into that same UI.
Yep.
Oh, it says we've already done that. Was there a complete to be hit on there? How about I log out of that session and close all of these leftover connections and trigger that expand again. There we go. This time it wants me to log in, so it should have lost all the session credentials from the last one. And did I type my password wrong? No.
No, very good.
Good job.
You know, it's still showing us that we've added our storage node successfully. What I really want to do is come back and start again. We'll return to the welcome step. There we go. Are we adding compute nodes? So the same wizard again, but this time yes to adding compute nodes, which means I have to agree to the license agreement from VMware again. Yes, yes, Pat, I agree to your license agreement.
It's those pesky license agreements.
vc.lab.local is my vCenter. I'm in two minds about this not storing all of my credentials for me. I quite like that you're not storing my credentials, and then it's inconvenient that you're not storing my credentials. And I think I mistyped that, so I'll try it again from the start. We're going to add our compute node to the existing data center, which is the NetApp HCI one. This tells me we're definitely connected to my vCenter server. Add it to the existing cluster. And let's set, there we go, set a password for the root user. I'm going to type that. Passwords must match, which means I need to type them correctly twice in a row. There we go.
It's always fun when you just cut and paste and mistype it the first time.
Yes. This is why I like password managers that will fill it in for me automatically. Again, doing that discovery off the auto-assigned IP addresses. We've got no storage nodes left to add, but we do have a compute node, and this one is running at 20 cores rather than the 8 that we had previously, and twice as much memory.
Score.
Yeah, although as a vSphere, configuring up HA on this concerns me, because now I've got one node that it constitutes half of the resources of my cluster. I should buy another one of these in order that it only consumes a third of the, makes up a third of the resources.
That's actually very important for the storage nodes as well. So you added a storage node that was larger than the ones originally. You cannot actually add a storage node that's larger than 1/3 of the total capacity of your cluster, because just in case you do lose that node,
That risk is too great. Yeah.
Exactly.
30 ESX server, and again, just copy and paste out of the spreadsheet that was kindly provided by the unstoppable Kevin. Management IP address.
I now have a new challenge of trying to stop Kevin.
Sorry, Kevin. And then we iSCSI address A. I think we have an A and a B.
So the reason we actually have an iSCSI A and an iSCSI B on the hosts, but not on the storage, is that we actually use ESX multipathing from the hosts. So the ESX host will establish 2 storage paths from the 2 different adapters that you've given to the nodes, and be able to multiplex across the paths.
Is there guidance around how I should set up that multipathing?
There is guidance. It's you should actually set it up for round robin, and I'm pretty sure that we actually set this up properly when you install it for the first time. and you should set up the number of IOPS to be somewhere like between 7 and 10.
Right. So not 1, but not 1,000, which is the default for round
So the whole reason for this is you want the number to definitely be lower than your queue size. What you typically find is if your number is larger than your queue size, you fill up one queue and it has to drain before you jump over to the other one. You don't want it to be 1 because there actually is a little bit of processing that ESX has to do for a path switch. And so you don't want to have your ESX host
incurring all that penalty.
Exactly.
But somewhere in the order of half the queue depth is going to be a useful value.
It's very easy to see if you actually do a TCP trace of when you're actually path thrashing due to round robin versus when you actually have both queues full.
Right. All right.
If you actually want to dive into that deep.
I think that's probably best done in a dedicated session where we set up the lab and can generate a decent amount of I/O.
That's actually a janitorial task.
Maybe we will have janitorial build day live with just Andy and getting very deeply into the depths of storage analysis and fine tuning, which I know is a very deep topic.
Sounds good to me.
Well, Andy, now while we're waiting for this additional node to run out, and since you've shared such a lot of the insights of how this works and some of the fundamentals of how iSCSI works with these scale-out storage systems, thank you for joining me.
All right, so we have another question from the gallery here. Matt Judson asked, can you mix and match SE drives, or SED and non-SED drives? Which I think I can answer that. You basically have to turn the encryption off on the drives to use that, right?
That is correct. So we can still support it within a cluster, but the best practice would be, we would try to stay with self-encrypting drives. So we do, we put in that practice to, work with the NetApp team, work with your partner to order them, and we try to make sure that we are ordering those encrypted drives. But if you did have that case, or you brought a node back from another country, you could certainly intermix it within the cluster.
All right, and our deployment of the third ESXi server is still in progress. It's still just setting up ESXi in there. So we're going to have a look at that ActiveIQ that both you and Andy have mentioned is a really important part of the environment.
Yeah, so what we did, and again, that checkbox is part of it. Do we want to enable ActiveIQ monitoring and reporting? And we said yes. And what actually happens, because we're in the Boulder office, is we actually have it set up so that our internal systems are put in staging. We want to eat our own dog food, and so we put every internal system in there, and automatically what happened, this was a challenge, right? We're trying to figure out, where is it?
Looking in the normal customer area for this new cluster we've just deployed.
Exactly, and it did show up. It was just in the staging environment that we got into last night, and found our cluster and added it. But since then, we completely destroyed that cluster and we brought it back into, we redeployed. So what we're going to actually look at is, I have a lab environment that I've been using a lot. We have a few SCs that, my counterparts that use this, whether it's for, helping us learn or using for customer demos. So we can look at that one.
So there's no history on our cluster. We could show you the cluster we deployed an hour ago, but it's not going to be very interesting.
Correct.
So this is your cluster then, Kevin, we've got 3 compute and 5 storage nodes. So it's the same scale as what we've just scaled out to.
Yes, it is. And when I meant at the beginning, when we look at the vCenter plugin, every time you look at it, we'll go to the reporting page. And within that reporting, maybe not every time, but when you click the reporting page, what it's going to show you there is, what is the capacity utilization right now? What is the performance of the system? But it starts capturing right when you bring it in. For that long-term historical view, we have our ActiveIQ. Now, one of the big factors of our whole system has been automation. Mm-hmm. So what's interesting about this is I have customers, whether they want to use Grafana or another tool to monitor, they're like, how did you do this? What metrics are you looking at? And as we go around in here, if you actually click on reporting, and click on API collection. So this will actually show you exactly where we're pulling our data from. So these are the statistics. with the collection interval that we're pulling off of your cluster.
And this relates to the fact that the origins for the underlying storage system here is with SolidFire, who initially targeted service providers. And for a service provider, you give them an API and they integrate it into their automation tools. And so you've always been API first. And these are just the API endpoints that are provided by the SolidFire cluster.
That is correct. So there's nothing in here that you can't do. You know, whether it might be a formula that we've created to display it differently, but we are exposing all those metrics for our customers to consume, whether they're using our tools or their own.
And then they can make their own meaningful reports and dashboards out of those same metrics.
That is correct. Nice. But instead of just looking at automation, let's actually look at what the visual interface can provide. So we can go back up to dashboard. And as you mentioned, Alistair, it shows we have 3 storage nodes and 5 compute nodes now. So it's detecting this, and we can, well, this one's my setup. I just forgot, because we are actually expanding our system to 3 compute nodes and 5 storage. But if you press show details, it will give you a little more information on this. And we can see, you know, what we're running. So this is running a version of 11.3. We have ESX, and it gives us right here what our vCenter is. So, you know, we know what vCenter we're connected to, and you know, as part of that consistent deployment, we're deploying it. And we saw this with yours as well. We created that new data center and new cluster within it. So we have our NetApp HCI data center.
And I also noticed that you've got a much more consistent cluster than we have, with 3 compute nodes that are all H300s and storage nodes that are also H300s, whereas ours is a little more diverse to show that capability.
That is correct, but actually on my walk over from the hotel this morning, I was talking to a colleague that's looking to, he has 5 of our older nodes, and he was upgrading the code today to integrate it as well. So whether we, you know, it's deciding, are we going to just deploy a new cluster so that, you know, if we want to rip this apart and move things around and do that, we can, or we can actually just add those right to this cluster.
That was nice. That was something we also talked about with Andy. So what other great information are we getting in here?
Yeah, so pulling down a little bit, it does show you your overall compute utilization. So that's showing what we're doing right now. Shows some capacity and performance metrics. But you know, maybe we want to go a little more granular. So let's click on the under reporting. Since we already scaled that down, we can click on capacity. And so from here, by default, it's showing the last 7 days. And we can actually see that some workload got moved onto it about a week ago, because we can, you know, we actually did a rebuild of this cluster recently. Right. We wanted to say, you know what, we're just going to scratch this thing, rebuild it, test the new code out, and bring it back up to speed. So what we did there is we also have an ONTAP system. So we brought in the ONTAP system. Everything's attached. It's another thing. When you look at our NetApp HCI, we are providing these hybrid cloud control services. So hybrid cloud control today, we have NetApp Kubernetes Service in preview. We're going to be showing that. And shortly, we'll be releasing cloud volumes on HCI. So that's going to give you the easiest console possible to be delivering CIFS and NFS services back on your same HCI cluster. But we also have that full support for integrating with our ONTAP systems. So whether you're integrating it like we did in this cluster, where we have it attached, so that we, you know, all of our images are off of that. So we have our repositories and where we store all our templates and other things, but also for SnapMirror replication.
Right. So
before we destroyed this cluster, we SnapMirrored everything right off.
So SnapMirrored from the SolidFire origin Element OS storage cluster to the ONTAP platform. So completely different lineage of storage platforms, yet you're shipping snaps from one to the other, and then bring them back again.
That is correct. And you know, I work with a lot of global companies, and some of the globals that we're doing that quite a bit right now is, you know, they want that flexibility. You're buying HCI as this simplistic platform. We're bringing in NetApp HCI, but what if they wanted that data protection to be on our system is all flash. We want to protect
your cost per
it.
gigabyte of storage is relatively high. not ridiculously high, but there are lower cost per gigabyte of storage locations, like potentially still having some spinning hard drives, and the ONTAP platform is the destination for your data protection.
Correct.
Yeah, nice.
So back to this page here, what we had is we're showing kind of the used and how far. We've grown a little, so this is where capacity forecasting comes into play. And we see here that we have a warning threshold, error, and total capacity. Well, when Andy was in here, he was talking about how, data protection, if we lose a node, we're not in a failed state. We actually, we bring it back to full HA again in under an hour. And that's where that error threshold comes in. So that's really, when I'm talking to customers and what to look at, it's that state. Once you're past that, maintaining under error threshold is where you allow that node to fail and be back to full HA. So that's,
and warning threshold is a node failure plus multiple drive failures. By the look of it, that threshold, in order for me to be at the warning threshold and still get to a situation where data is at risk, I would have to have a full node failure plus multiple drive failures in the surviving nodes when I'm at that warning threshold.
Well, what we've actually done with warning is it's a percentage of under error. And you can change your warning threshold so you're getting all of the alerting that we can integrate with. But the point there is, if your buying cycle is going to take you 3 months, then
yes,
maybe you need to move it up from 3% to 6% or 10%, so that hey, I'm going to hit error threshold in 10%. Give yourself enough time to get through the procurement process to bring a new node in, find that window, that monthly window oftentimes that you're going to be allowed to add it into the cluster as well.
I might have just written about exactly this issue for Tech Target that'll be published very shortly, but you definitely need your capacity thresholds to include all of the non-technical time of approval and ordering and delivery.
Yes.
Absolutely. And in this case, we only see 11 days between the warning threshold and the error threshold time, and we probably in a lab environment can cope with that, but probably not in production if we're seeing that same trend.
Definitely.
What else do we see in here?
From this page, it's showing block capacity and metadata, and that's because we separate those two services out. And when customers ask me, so when do I have to worry about metadata capacity? And really, this comes in because our architecture is always on thin provisioning, deduplication, and compression with zero performance loss for those. Now, if you're getting extremely high efficiency ratios, that's where metadata may come in to start filling up. And we've had it where we can define more metadata if we needed to. We could add that second node in. So we've seen that. I've seen that in the past, but it doesn't come often.
Right. And this is that you dedicate physical storage device for metadata in the architecture, don't you?
Yes, we do.
And so then you would just be allocating another physical storage device in the node to provide more metadata capacity.
Correct. Because of that scale in, scale out architecture, we could remove a data drive and add it back into that pool if it was ever needed.
And that again means that there isn't a situation where I'm out of one resource and have to buy a complete new physical node in order to get more of that one resource when all of my other resources are underutilized.
That is correct. So then let's move into efficiency, because efficiencies are always something that comes up. What kind of efficiency am I going to get? And this shows these trends over time. We went up, we went down, and that could be thin provisioning, but what do we see here?
Well, there will have been some things going on around ingest of those snaps as you're restoring back.
Yeah, when you create a cluster, we saw that here, right? We created this big this cluster. We got, I forget what the default is. I think it's two terabyte data stores.
Yes, that's what we got provisioned.
And we have a 200 gig, 400 gig VM in there.
Mm.
So when you look at that, the rest of that space is thin provisioned. And so we start exposing those big numbers just because we're not actually consuming that space yet. So as we start consuming, we see those numbers kind of level off and come down. But what we have here, as you're showing, though, is the average dedupe and compression ratio on this lab cluster is at 3.3x. And NetApp does have efficiency guarantees. So for our customers to, if they are interested, we can always have that.
So those guarantees will be around the raw storage versus the usable capacity, And if I've got a particularly odd data type, maybe I'm dealing with massive non-compressible data sets, then there might be a place where NetApp would have to provision me additional storage to be able to store the amount of capacity that was guaranteed.
That is
those
correct.
kinds of guarantees. Those are useful to customers who have very weird data use case, but they're usually not a lot of risk for NetApp because most data types compress and dedupe really nicely.
Yes, definitely.
Particularly if you're only relying on a 3, maybe 4 times.
One question that's coming from the chat here from Joe Zoda is about that and SED drives. Do they miss out on any? Is there any difference on the storage efficiencies between the drive, an encrypted and non-encrypted drive?
Because we're using self-encrypting drives, all the encryption is done on the hardware level. So it has no effect on what we're doing in the element software level. So it does not affect your efficiency ratios at all.
And this is the differentiation between using the encryption at the vSphere layer, where the data arriving at the element OS is already encrypted, and therefore it's hard to compress and dedupe, versus using the self-encrypting drives that are on the other end of the data efficiency, right down at the physical storage.
Yes, exactly. And the other thing with these efficiencies is they can continue to scale. It's global efficiency. So if you start with 4 nodes, you go to the 40-node cluster, the deduplication isn't tied off to different drives or nodes or anything else. It's global
across all the data set. The other interesting interplay between encrypting at risk and deduplicated systems is that we're usually trying to protect against somebody stealing the hard drive and getting our data off it. Well, it's deduplicated, compressed data that's on there. You'd have to work out how to rehydrate and uncompress the data. The actual data layout is not very, very clear. So encryption at rest is definitely for the paranoid rather than for the mainstream. Although if there's no cost penalty, why would you not buy self-encrypting drives if you're allowed them?
Yes. And the fact that the metadata is somewhere else. So
yes,
we have that dedicated as well, making it even, you can't do much with the data at that point. Which makes it also, you don't have that penalty as we move things around. So Andy talked about this and how we just dynamically move the blocks. And that doesn't just, so that happens as we scale the cluster out. It just moves the existing blocks around and rebalances the cluster.
And that would have been going on in the background after we added our additional storage node.
And it actually, even more than that. So part of our garbage collection, and all of this is automatic. You can't change, you're not going to tweak that or change it. But what we do is we optimize the data layout. So as there's always going to be in storage, there's going to be blank spots that get created as data is written and deleted. Well, what we do as part of our whole process there is we bring the live blocks back in and just keep writing it out. So essentially, what you come out with is a clean, even if you're 20% full or 90% full, we're not trying to find the holes.
Right.
Just keep writing.
That's really crucial as you're using a deduplicated and compressed environment. As it gets very full, you can get into a situation where you have significant performance penalties from some of the assumptions that you made about the media characteristics.
Yes.
Less so with flash than with hard drives. Hard drives were terrible for that.
Yeah, definitely. And then other things to look at on this page is we'll go down to performance. And so the performance on this is down to a, kind of what we're seeing in the utilization of the cluster, IOPS and throughput. So we can always highlight over an area. The other interesting thing is there's that, underneath that line, we see one of those spikes. So if you scroll your mouse down a little further.
There's no further down on this one.
Well, what I'm right in this little bar, if you highlight over that area.
Yep.
Actually zoom right in. So you don't have to mess around with what time you want to look at. You can just do it very easily.
And I can drag the bars and...
Yeah, so we're just looking at a point in time, and we can change between that to make it easy to...
So I've got a time scale at the bottom and a detail view above. Nice. Does it respect that as I go? And it respects that as I go between the different views as well. That's nice.
And then as we go down here, let's say we're running into it, and you're hearing back, and we don't report the volume name within here. But if we go down to the volume level, so this is under reporting. So we kind of go down to volumes next. And being a lab environment, we really don't have a workload going today. But we can actually get to, we see the quality of service bands that are configured for each of these, but on the far right, you could actually go to Actions and click the 3 dots on one of your volumes, and you can go into details. So this is, if you needed to, and this is on the storage layer, but if you wanted to look at what is exactly going on, what is the latency that you're seeing on that particular volume, you have all of those details right here.
All of the things that your storage administrator traditionally is looking at as they're helping you troubleshoot issues with your applications.
Correct. Other things I like to look at is, as we talk about quality of service, and if you go back to the active volumes tab, we have some different quality of services configured. We can see 20,000 burst and these different maxes, and customers often say, well, what do I need to configure? How do I need to consume this? And and if they don't, whether it's service tiers, especially you mentioned service providers, and coming out of there, they can do cost-based service tiers based on quality of service bands.
So you could just do a very simple gold, silver, bronze kind of tiers of service and have just 3 policies that might be applied.
Yes. But in our system, we do everything on the minimum level. So instead of trying to limit your quality of service, we really want to guarantee, kind of hit that minimum threshold for you. But what often happens, and if we're talking to a remote site, maybe they don't know those details. And wherever you start, we actually brought in right into ActiveIQ, no upgrade, because this is our interface, just came in one day. And so you have QoS recommendations. So that is actually looking at, and we can click on that. I'm not sure that we'll see some. So on the left-hand side, towards the bottom, is QoS recommendations. And we are starting to look at, so there's no maximum recommendations right now, and it's saying, look at this, volume 3 has 1,000. What this is telling me is those volumes aren't even being used, because it's 100% of the time is below the minimum.
So the minimum is the minimum IOPS that are guaranteed.
Correct.
You can't have a minimum that's actually going to be delivered. It's the minimum. This is a guaranteed amount of IOPS. In VMware's CPU, the same kind of measure as the reservation. It's the guarantee that it's going to be available. And it doesn't work the same way.
Yes, it does not.
But here it's telling us, this is a lab. You're not doing anything with this equipment.
Yes, yeah, and and where you meant, you're talking about reservation, and that you're actually physically reserving that space out within VMware, and we've all probably run into those where you try to add a new VM and you're like, hey, my cluster's not using anything. What do you mean it's full? Now with us, what we're doing is, we have minimum, we have maximum, and burst. And I had this customer, a big, another big customer of ours, a networking company that I've been working with, and they did everything guaranteed on the minimum level back to their end users. And what we were talking about is how they could better utilize it. So what we actually recommend, and what a lot of our service providers are doing, is you're taking it, you're guaranteeing that minimum level, but that's not your SLA. Because we don't want to physically reserve, like in that VMware example, that if we have 200,000 IOPS in that minimum cluster and we set everything at 10,000, what happens after that?
You get 20, and then the next one can't be created, can't be allocated there.
So so what happens in ours is, let's say, everything was open, right? So you had that 10,000 minimum and 200,000 max and burst. Well, what would happen is if there's pressure on the cluster, so your cluster is running at that 100% utilization, it's going to start bringing all those volumes down from where they're running. So if there's a volume that's running it's running at 40,000 IOPS, and it's got that 10,000 minimum, it's going to just kind of scale that back.
It's going to be eased back down so that everybody gets the 10,000.
Exactly. But in this case, we have a bunch of volumes that are not even being used. The other volumes could use their IOPS.
Right, because that is, it's drawn from the single large pool of guaranteed IOPS, and you can only draw from it so much. Recommendation here is just ease them back for the ones that would be light.
Yes.
But if this is a real environment, then something with a high I/O critical load, you would bring the minimum bit up on that load just to guarantee that service level. by the minimum.
Yes, exactly. I try to find those critical workloads, have the highest minimum, and then to really make sure they always have that performance. The other thing is, Andy talked again about the data layout and how we do this. Well, the data is laid out in the most optimal stance up front.
Right.
Everything is spread across every drive. The data drives for data. When you adjust this minimum, it does not have to do any data movement.
There's no moving from tier to tier because you don't have tiers.
Yeah, it's almost like we're limiting more than we're adding. So if you go and change that minimum from 1,000 to 10,000, it has that performance now.
Right. Nice.
And the last thing we could look at here before we can check on our ad
ESX server. Yep.
would be the virtual machines. So what we're doing there is we're bringing in the virtual machine list. We're bringing in VMware alarms so we can kind of see what is going on, which servers are on and off, and easily do filters. So I see a couple off, so you could even click that plus on, I think it's powered off, would take that off. So that actually did the opposite. So
it was already filtered for only showing us powered on machines.
It actually shows off here, so if you click on powered on, that's what I meant to do. And now you can just see the list of powered on VMs.
We can see a fair number of stats of the vSphere layer stats coming in.
And the other thing too is if customers want to go even more granular, we integrate our HCI right with our cloud insights. So as part of NetApp's whole data fabric vision to be fully connected and allow that monitoring, we can bring NetApp HCI right into there. And then you have that full granularity down to, from the hypervisor down to which disk and which data store that it's on. Point and click right through it.
And there was an awesome demonstration of Cloud Insights at TechField Day 19 when I was there in where was I? San Jose a couple of months ago. Absolutely awesome demonstration. So it's worth checking out that TechField Day video if you're interested in Cloud Insights and more. Let's take a look now and see our newly added node, our newly added compute node, because it's now successfully been deployed. So we'll close out that guy. And what we should see going back into our hosts and clusters view is that, yes, we've now got a third ESX server in our cluster, and of course it has that same CVE, which I'm going to suppress so that we actually see it, if there are any actual errors going on in there. So now we have our 3 nodes in our compute cluster, we have 5 nodes in our storage cluster, lots of capacity, lots of space to run some things. So why don't we run a workload in here?
All right, sounds great.
The workload we were choosing was the NetApp Kubernetes Service. So moving on from traditional on-premises vSphere infrastructure to something a little more cloudy, since we're keen on cloudy things. Where do I go to get started with the NetApp Kubernetes Service?
So what we need to go now is if we still have that other page open, which we may.
Which one would you like? Let's close out that console because we don't need that remote console anymore.
Where we had the deployment engine.
I've closed that deployment engine.
Okay, so what we are going to do here, and this is off of memory, but if we don't have it, let's go into the deployment guide because it has it all written up and documented there. Let's go into, this is the M node IP, so the management node.
168.199.9, yep.
/
How about we go to manager dashboard,
yes.
because I think we might have been there before.
Perfect.
Let me, okay.
There was no capital.
Just my preference for, there we go, that's the administrator. And caps lock is off. This time, I typed the password correctly.
Okay, so this was the other interface that we could have went to expand that cluster. The monitor cluster would have actually launched you right into that ActiveIQ.
So that's the monitor goes to ActiveIQ.NetApp, expand, takes us to the same UI that the plugin took us to for expanding. And we've already looked at the upgrade, the fact that we're already fully upgraded at deploy at the moment.
Yeah, and when let's click on, and what we're going to do here is enable hybrid cloud services.
That sounds fun.
And what will happen here, though, is that that first button that showed upgrade the install is what we have right now is we have NetApp Kubernetes Service in a live preview mode. So our customers can go try this out right on their NetApp HCI cluster to be delivering the same services that we deliver in the NetApp Kubernetes Service that's offered between the different hyperscalers to also bring it into your on-premises NetApp HCI.
So I can get Kubernetes as a service from public cloud. This is now giving me Kubernetes as a service, not a science project, on premises.
That correct. And we've designed this. There was a commented chat. You should never. One of the guys said you should never be deploying, base Kubernetes.
You should never be rolling your own Kubernetes,
Yes.
says John. And that suggests that Kelsey Hightower's blog post about Kubernetes the hard way is letting us know that there is an easy way now too.
Is with this thing then is that time trialed, or would you have it from day one to day?
So what's the prereqs before I can actually enable this on my HCI cluster?
Yeah. So one of the things is when we have to create an account on nks.netapp.io. So we'll go and create an account there, and when you create an account, you get a 30-day trial, and so that's what we can use then to deliver these services and test it out.
So, but is there a minimum version of the NetApp HCI platform that I need to be on? Presumably, I would need to be updated to something fairly recent for this to be enabled.
Yes, we would need to upgrade it. We would need to update the code. Now, with the release that we used here, we saw that when we clicked the upgrade button, it was already done. Now, if you're on an older version, we'd bring that newer M node up to speed, or up to the latest version, and then you have to click that upgrade services, and that would bring the latest service bits into the cluster. Now, once that's there, we can enable it. When we come out with these others that you see here, Cloud Volumes and Cloud Insights, right on NetApp HCI, that's where that upgrade button is going to come into play with our system that we have, because it's already upgraded.
Okay. Well, we'll continue on and build ourselves a NetApp Kubernetes service here.
Okay, so this is that question that you just came up with, is where do we go? So it's got we can click that link there. Let's just open it in a new tab if it does that. And we pre-provisioned an account that's never been used.
Tell me if I've got that wrong. Now we'll find out whether I typed that collection correctly. It looks like I have.
So now we are in our NetApp Kubernetes service. So what we need to do first is create a token. So we're going to go to our profile here.
Edit profile, preferences, credentials. This is API tokens. No tokens found. Add token. Yes, please. One token. Token for HCI.
And when you create this token, you do want to store it. It's only showed here temporarily, and then you won't be able to grab that again.
So grab that, paste it back into the one place that it's needed, and connect. And so now my on-premises NetApp management node is going out to talk to a web service and registering and establishing that relationship.
That is correct.
And so Frosty Sound, that looks like a very container name. Two words joined together.
Yes, and that comes from your profile. So it looked at your profile that we just created, and we're back in there. We'll see that Frosty Sound, and we can just make our name.
Somewhere up in my profile?
Yeah, it should
It'll be somewhere in there.
Either that button or the Kubernetes right on the top. There we go.
So I could have another organization in here. All right, so I'm going to say that we're currently in Boulder of the Frosty Sound organization. And we want to be in our NetApp HCI data center and cluster.
There's actually one thing. We need to build out those port groups, because we were going to have some dedicated port groups.
You know, it's a good thing that you're here with me, saving me from getting too far in front. Because, of course, we do need some networking for the Kubernetes elements. Remind us again what were the 3 networkings we needed?
So what we're doing here is we have all these networks that are shown that are created by default, but for Kubernetes best practice setup on HCI, we actually want to create 3 new networks. So we're going to create a management network. So this is going to be for that management side. We're going to create a user network for the different containers to talk, and then a data network so that it can talk directly to our element storage.
And I've pre-created the VLANs behind and set up DHCP on the subnets that are underneath these VLANs, and set up routing so that the workload and management networks can both get to the internet to talk to the management service. But the storage network that I'm just adding is the final one. That for NKS, that has DHCP on it, but it doesn't apparently need routing out to the internet because this is our normal storage network. This is the same storage network that the ESX servers are consuming the storage cluster over.
Correct.
So I really don't want to route from there to the internet. That's a VLAN 17. Great, now I have my three networks, and the standard vRTA router that I use in the lab has these 3 networks connected to it. Cool, we pop back in here and we go continue on this one. And it's a good thing that we created those before here, although I'm going to have to refresh that list. There we go. This is the management one, workload network. I'll refresh that list too.
Oh, that actually refreshed the top.
It clears the whole lot, doesn't it? That's right. And then storage. Okay. So here's the things we're going to do. We're going to build out NetApp Kubernetes Service, make it available with the Boulder region, talk to vCenter, and use these existing 3 port groups. Enable services, and it says it'll take some time. So the enable is running at 85% now, so it's getting close to finished. The thing is, though, this is deploying infrastructure on top of our vSphere environment. So I'm going to pop back across to the vCenter server, and what we should see here in the host and clusters view, and I'll close up the cluster I brought with me, is the beginnings of the actual new deployment. So there's, in fact, it looks even better if I go into VM's view, because there's a folder containing all of the NetApp Kubernetes stuff. And so there's a bunch of virtual machines that have been deployed, which is really cool.
Yes, definitely. So what we see there is that we have a master server that we're creating. So that's going to be that Kubernetes master services. And then we have 3 worker nodes within the pool that we're starting with. And that's where we are with this build. So we're building this out and getting it all integrated. And one of the other pieces that we've done, and we talked about our Kubernetes services, it being upstream Kubernetes. So we're not developing off a fork or anything else. And one of the auto manufacturers I've worked with it was exactly a challenge that they looked at when they were looking at some of the other services that are out there. Their developers started actually in Amazon, and they saw the challenges with the master service being locked down. And then when they started looking at things, they wanted to bring the actual production workload into their on-premises environment. And
so they were doing Kubernetes-based development in public cloud for production deployment on premises.
Well, it started in public cloud because of resource constraints. How long it took IT too long to deliver services on premises.
I'd certainly not want to be the IT team on premises building Kubernetes as a service.
Exactly, but what they actually did is they purchased NetApp HCI. So they started out NetApp HCI using another platform for Kubernetes. They're using OKD, and now they're at the stage that they're ready to evaluate our NKS service on HCI so that they can simplify further. What I mean by that is they're not having to, with this service, we just built out the VMs right here by default. What if you need to upgrade the service? And what goes into that when when Kubernetes releases
With
a new
another point
security
release.
patch?
Yeah.
And what we've done with our NetApp Kubernetes service is it's one click. So we click one click, upgrade to the next version. So we're very easy to upgrade and scale. So we'll actually, I think it's a good idea to scale this out even when we finish this deployment.
All right. But this is the infrastructure component. So if we pop back into the wizard, it says your cloud services have been enabled. Congratulations. And now we have one of one services has been enabled out. Where do we go to manage this Kubernetes environment?
So from here, we'll actually go to that same interface. We went to nks.netapp.io because now we're actually working from cloud services. So when your customer deploys this, and when you guys deploy this, you can pick where you want to do it. So that example that we just talked about, let's go to control plane. I'll kind of explain where I'm going with this, but we aren't tied to just NetApp HCI now. So when you click on Add Cluster, what you'll see different. And if we launched this before, and it kind of just popped up really quick, was it brought NetApp HCI to the top. So once you enabled that service, it brought it in. But you also still have these other services. So if you want to deploy Kubernetes on AWS, just the same upstream version that we're using with NetApp Kubernetes Service, we can manage that. So we can manage all of your cloud-based Kubernetes deployments as well as your on-premises Kubernetes deployments right from the same platform, same interface right here.
So we've got a very diverse range of places that I could run NetApp Kubernetes and just manage it all from this one console.
Yes.
And so that portability of using Kubernetes and Docker containers underneath is truly here in terms of being able to take the application and uplift it from one location to another.
Correct. And then as we are in preview mode as it shows for NetApp HCI, but we'll be bringing in Helm charts. We're bringing in Istio, making this all very easy to consume, and then the ability for you to bring in your own charts. So bring in, what we'll deploy as a sample application, but we could actually brought in a chart here, and you'll be able to, when we come out with this in production, you'll be able to use those applications in your charts to be automatically click and deployed on your cluster.
Step me back one moment, because not all of our audience is familiar with Helm. What am I getting out of having charts beyond what we're going to show here with a YAML file to deploy an application?
Yeah, so with Helm, we'll be able to much easier package and deploy applications and bring in your applications. So we have a list of trusted chart applications already. So that could be what we've been doing a lot of work on, is bringing in these services together. So typically you wouldn't see Elasticsearch by itself. So we bring it in Elasticsearch associated with Kibana and one other. We would have to look.
Usually.
Yes, thank you. And so we bring all three of those services into a packaged chart.
Right.
And
so it's a collection of microservices that are brought together to deliver a full application.
Correct.
Nice. But at the moment, we're waiting for that to be added to this particular deployment on NetApp HCI.
That is true, yes. If we clicked on like AWS, for instance, we'd see some of those charts in there. We don't have, just like we had to associate the API collection. Mm-hmm. What's great about this service too, though, is we give the exact instructions where to go. So, when I first started with this, I think within a week of us acquiring the company, I went right into here, and I didn't have my AWS credentials created for external access and that, and it was literally just walk right through the document.
Follow the bouncing ball instructions. So as we're deploying here on NetApp HCI, what am I doing? I've got one master being created, 2 workers being created in my Boulder because it's the only location I have. Default workspace, SSH key pair. We'll just go ahead and make that for me, please.
Okay, and so this now, just like we had Frosty, now we have Raspy, and you could change it, or even click that little circle to change it again.
I don't want glitter. Oh, I don't want a shrill scene either. There we go, delicate sky I can approve of. It may not be an elastic one, but it is a delicate one.
It's been a little delicate out here with the hail and everything we've had this week.
We had 2 days in a row of really brief, really violent storms throwing down pea-sized hail, and that they coincided always with when finish of work as we're heading out back to the car. So it's been interesting being here. It's mostly been beautiful blue skies here in Boulder. Just these little narrow storms have struck us a couple of days this week. Feels a bit like being at home because the weather changes so fast.
Yes.
So we've got our Kubernetes version that we're in here. We're going to install the dashboard to go with it. Got some networking going on, some underlying, defaults. Seems good. And you can see etcd for our key values as well.
So what we saw when we were in vSphere is we built out a service cluster up front. So that's based on the services that are running now. So now what we're actually doing is we're building out that end user cluster that we can start deploying different container-based applications off of.
Right. And so we can see the master node spinning up now in that new Kubernetes cluster. And presumably if we come in here, we've got a state here is deploying at the moment, and as we drill into the cluster, we can see that state. Where are we? Pools, default pool. You can see our 2 worker nodes and our master node all being deployed out.
Yes, and then once this is deployed out, we will have the ability to expand it as well. So we can expand out the worker node pool or even shrink it if needed.
It seems that we didn't make enough of an offering to the demo gods, and that although we've had much success today, we have struck a little challenge.
That we did.
As our lovely delicate SkyPod was being deployed out and new virtual machines were being deployed, we experienced a failure on that brand new to us node that we added to the cluster. Kevin, what was the history on that node?
Yeah, so this node, well, where we started is we have our rack, and so what we did is we brought in a node, and we were looking around, how could we demonstrate a cluster add? And so we actually got a node, like you were asking, where did it come from? It was actually a returned unit from a customer site that was in extreme heat conditions. Now, we were able to still rebuild it, but it, right when we put a workload onto it, it actually stopped responding.
So one of the things that you don't see as we do this event is that there's usually somebody who is running around scrounging equipment for us to bring together all the parts that we need with the peculiarities. We want to do the cluster expansion with a different node type.
Yes.
With a significantly different one. So Doug has been tireless in his chasing around finding the things we ask for. And here he's clearly pulled off the wrong disk, a node that was not ready to be deployed into production.
Yeah.
So the consequence is that we've had a node failure. We've made sure it's not going to come back and fail again. And that also happened in the middle of the deploy of our Delicate Sky cluster. And it seems that our Delicate Sky cluster is not very happy. And so we're following cloud-native methodologies. Rather than trying to heal the sick, we're going to build something new. So we have also, whilst Ingo and Keith were having a good chat, we've deployed a new Kubernetes cluster here on the NKS called Damp Fog, exactly the same configuration, but it didn't experience a failure of the ESX server in the middle of its deployment.
It's not so delicate.
It is less delicate. And of course, being here in Boulder, we don't experience the damp fog that you get in downtown San Francisco. So here we've got our cluster. It's been deployed out. We've got some IP addresses. These 172.19.2, that's on the NKS workload network that I added. And so these are valid IP addresses inside of our network that each of these Kubernetes hosts has. So we've got the worker node IPs as well as the master IP here. So what else do we get in here?
So, one of the things is you start deploying new workloads on Kubernetes, and we might run out of resources. How do we add to this and make it simple for our customers? So if we do that here, what we'd be doing is we'll add another worker. So we can add additional worker nodes right to the cluster. So what we have here is we have our default worker pool. You can create new pools, but we'll just keep it on this, and we can pick the number of nodes that we want to add.
We've got 2 nodes at the moment. Let's have a third one, so we've got an odd-numbered cluster size, which always feels more comfortable.
So what this will do is now it's going to push that out right onto our same VMware cluster. It's going to bring out another worker node right into this to deploy additional pods.
So, I can't even see where it's deployed because it's come up so fast. I was hoping that we'd see a powered off machine being created, but it's already powered on and starting up. It must be coming up as we go. Cool. What else can we see while that's coming up?
Another thing we can do is launch the Kubernetes dashboard. So we do bring in the dashboard by default when we are doing our, building out a new cluster. So this is, as I mentioned, it's upstream Kubernetes. So this is the same dashboard you would have, but without the painful
deployment process, all of that science project of building and deploying. And again, you're just providing the web service that's the nks.netapp.io is just providing me a redirector to get back to my on-premises Kubernetes cluster here, or Kubernetes cluster wherever else I deployed it with NKS.
Correct. So what we can do with this is we can actually deploy an application. So we can look at that.
How am I going to do that from here?
So where we would go from here is on the top right is a plus button. So we will go to click on that. And we can input from a file or just paste some YAML. So what we are providing here is just a basic Ghost application. It hasn't been edited. It's just, but we're doing that with persistent storage. So we're going to create a persistent volume claim against the pod, because as containers are ephemeral, we want to, as we start writing our blog posts, we don't want any sort of failure of a node to bring down pods or anything else.
Or even just a restart of a node would
yes.
be enough for a container to be restarted would traditionally be a return to its immutable state.
Yes. And so this takes a couple minutes. So we'll wait for this to show up.
We have one more pre-recorded video that we can pop in while we wait for it. I mean, it's going to take a minute or two to start up. So, well, now our application has been deployed out. The containers have been spun up, and we can see the deployment is successful in here. We've got our pods all running, which is nice. Of course, this is the container that we've got in here is a web server blogging platform. So I guess we need to connect to that. If we're doing this in production, we'd have a load balancer in front, wouldn't we? We'd probably have multiple of the web service and a load balancer that brings us out onto a friendly port.
That is correct. But even in this, what we've done with NKS is you can go to any of the nodes to connect into these pod applications. So what we'll go look at is let's find one of the IPs, and because we don't have the load balancer and DNS set up for this part, we'll grab that IP. Then we'll also grab the service port that we're using. And that's all just defined in the YAML file of the application and how we are using that.
So actually, one of the ways we can get that IP is to go back here into the damp fog cluster and just grab it off.
We just saw that it finished.
We saw that our third node is out, so we'll go pop the IP address in there, and then we need a port number. That was somewhere down here in the details of pods and replica sets and services. There we go. So we've got a Ghost service, which is the blogging platform we've got in here, and it's on port 31787. So node, port.
There we go.
There we go. Hooray, we've got our web service running there. And this redirection of a standard port up to a high numbered port is a standard Docker container, got Docker networking kind of behavior. So it should be familiar to people who are building applications on top of this.
Correct.
And so this is really just a web application now, which is looks reasonably pretty sitting here inside our Docker container.
And if we wanted to customize it at all, we could create an account by going to, adding the URL to /ghost. So the first part here, it's just going to ask us to create an account. So
And this is, to be clear, not a NetApp product in any way. It's just a very simple demonstration that we can have.
Yes, just an open source blogging application. And wants 10 digits there.
8. There we go.
Well, you can, at the bottom, you can actually skip this.
Do this later. There's nobody else working with me.
We don't plan to have this live, but too long. But we do see here, you know, on the top left, we can see that it says build day live, and we do have that.
So if I say, welcome to Boulder. Too many people watching me type.
So let's publish it. Top right, we'll just publish this page. We can do it now.
Cool.
And that is, and actually click on view post. Where would we find that?
Go. And there's a pop-up that disappeared. If I go back to posts, they're gonna...
There we go. So we can even just save this. So what I'd like to do now is, you know, we have this running.
Does it show up if I go straight back onto the front page?
You would actually.
There it is. There it is on the
there we
front
go.
page.
Perfect.
Cool.
Learning new platforms.
Yeah.
So one of the things with Kubernetes, and it really depends on how you deploy your application, but this application was deployed as a replica set. So if we can look at that from within damp fog, or actually from this Kubernetes dashboard, we see it right here, that we do have a replica set, and we have pods of 1 of 1. And that's based on how we have it set up. And the way Kubernetes will then work, and you know, especially if you're a Docker user and you haven't used replica sets, and you know, a simple application, you kill it, it's gone. Well, with replica sets, it's going to just rebuild it again, because it knows that it's requesting at least 1 to run, and if it sees none, it's going to
That's less
spin
than
a new
1.
one up. So let's go. We'll go up to pods. Right here, and we should be able to click those buttons on the right and just say delete. And we can see there that age hasn't been updated because we, you know, just haven't refreshed the page, but you know, we'll delete that. And then let's actually, okay, so this is refreshing for us. So we see the deployment down, and you know, with the replica set design, what we're seeing now is that it's going to be rebuilding it.
So it's going to build a new pod, but it's going to use the persistent storage that's being provided by the NetApp platform.
Correct, because it might not even be on the same node anymore.
Right.
We actually, this page does not refresh by default, so we'll just refresh that and see where we're at.
See where our pods are. So it says pods up. It's been running for 40 seconds. Let's see if the services have actually all started. Let's do a refresh on exactly the same URL. And there we go. It's come back again. It's still there. We can open the page.
Perfect.
Yeah,
So
our data persisted through the destruction of the pod.
Yes, it did.
Nice. So that's the end of the content we wanted to look at here. What have we done today?
So if we kind of recap what we've done, we started out with a cluster that actually was, you know, my mistake, but we didn't have any IPs, which is the most realistic you can get, because when you plug into a customer environment, there's not going to be a preset temporary IP. So what we did there is we set that temporary IP just to get into a cluster, and then we built it out right from our NetApp deployment engine. Entering simple IP ranges, it built out the full cluster of building out a storage node, full NetApp HCI deployment. From there, we expanded the cluster, so we showed that ability that we can not only expand, but we can extract as well. Not, you know, not typically how.
Not as routine an activity to take the nodes out.
Correct. But then, as you've seen, our NetApp HCI is really transformed into hybrid cloud to be able to deliver on-premises based services and have that same consistent services, whether you're deploying on-premises or within the cloud. And what we really did towards this end is we demonstrated what services we have available for that with our NetApp Kubernetes service.
Nice. And so we're building out that whole hybrid cloud idea that you're getting more cloud-like services on premises. You're caring much less about the underlying infrastructure, that infrastructure just always has to be there, whether it's yours or whether you're renting it from somebody in public cloud. But you want to care less and less about the minute detail of that underlying hardware. You want to make sure you have enough of it and that it's of good quality, but you're caring more about the services that you layer on top of it. And that, I think, is that transition we're seeing from the IT infrastructure professional caring about all the bells and whistles and the cables and making sure the IP addresses are matched up and looking pretty, towards more of the higher level services, delivering the infrastructure services that for Kubernetes they can be consumed by your developer community. Delivering more of those business, or more, they're still infrastructure services, but they're closer to what the business is asking for. I think that's a really nice transition to be seeing here.
Yes, and the ability to be agile with this, being able, we even showed expanding that Kubernetes cluster. We showed all of these different expansions so that as the business needs change, we're not having all these, we're giving that self-service portal to deploy these without adding additional resources, targets, and that. The system just balances itself back out.
It's a really nice set of capabilities, and I'm really impressed with what we've been able to show, particularly, Kubernetes is notoriously a science project to deploy out. Yet here we are, it took us 45 minutes elapsed time to deploy Kubernetes and then deploy out an actual application on top of a Kubernetes cluster. So Kevin, you've been working really hard all week, so thank you very much for being here, for being such a really useful resource, and also for all of the long hours that you've put in as we've gone through multiple iterations of building out that environment. So thank you, Kevin. Thank you also to my team, Jeff behind the camera doing his awesome job of the switching and coordinating and making us all look good. Also to Tracy, who's been running all the social media for us, and I believe quite a lot of you have heard about this event through that social media. Stay tuned for more Build Day Live events. Tracy will continue to be doing an awesome job. Naturally, there has been an army of people helping us here at NetApp. Doug has been our primary person running point for us on site, making sure we have the things that we need. My first contact was with Tim Aldrin, so thank you, Tim, for everything you've done for this to bring us to here. Also, Andy Banta, who was sitting here beside me, he's been a constant back and forth, making sure we had what we needed and that everything was going to be shown well. Thanks also to Michael White for his contributions and helping along the way. Diane, who rushed in here to make sure that despite having had a node failure, we would still have a functional Kubernetes cluster. Thank you, and also thank you, Kevin. Kevin, yes, for helping us through finding out what was wrong with my infrastructure the first time we wanted to deploy the NetApp Kubernetes service. Also with us, of course, you saw the video from Keith Townsend, the CTO advisor. It's been great hanging out with him and with Melissa this week. And do check out the CTO advisor YouTube channel. There's lots more great video content on there. Jeffrey, have you got some closing thoughts as well?
Oh, yeah. So I'd also like to thank everybody on the chat that has asked the questions and that has joined on. We were on YouTube, we were on Twitch, we were on Facebook, we were on Twitter. So tell us where you like to see the Build Day Live. Of course, builddaylive.com/NetApp for this build day, and check out all the other build days. And of course, if you want to have your own build day, let us know, and we'll go from there. And thanks to Alistair. Let's give him a hand. Give him a hand. He did a great job, right?
This has been really fun. It's really nice people doing great work in a fabulous location. So stay tuned for more great Build Day Live, and we will see you on the intertube soon.